Hello, hello, hello. So welcome to the AsyncAPI conference. Thanks for joining us. We were just speaking, the three of us here. Like we're thrilled. Thrilled to start this conference today, and we're terrified as well. It's the first time we're doing a live thingy, like on YouTube. So it's amazing. It's it's a challenge for us, right? And so yeah, we would like to start by I would like to start by introducing Lucas Gorniczki and Eva here next to me. You can see her here as well. So Lucas, you may know Lucas from the community already. He's been taking care of the community, and Eva is the one making the magic happens behind the scene. So she's the one in charge of the live video and the live streaming, and taking care of the magic happening behind the scenes. So we'd like to give a round of a virtual round of applause for them, right? Because they're doing a great job here. Right. So yeah, and so I'm gonna transfer my word now. I don't think this is the right expression, but anyway. So Lucas, maybe you want to add something. If not, that's fine. That's sorry for
Yeah,
this.
I'd like to add that some info about how we run the conference. If you don't know it yet, so we're doing it in pretty async fashion. So the presentations were actually recorded by the speakers a few days before the event. So and the conference looks like this: that we are streaming live the recordings, and the presenters are with us here for the whole talk. So you don't have to wait until the end of the presentation like on the usual conference to ask questions. You actually have this luxury that you have the speakers focused only on you through the whole talk. So ask questions at any time you want, and they're gonna answer. And the good thing about asking questions is that we somehow wanted to give back to you, this awesome community, that like all the speakers that so quickly responded to our call for papers, prepared all those proposals, like the whole community that you're with us now at the moment. We wanted to somehow give back to you, so we prepared a vouchers for our swag shop. So we have 12 talks. So we have 12 vouchers for you, for people that ask questions during the event. All the details about the vouchers I'm gonna paste before every talk, so we know how the rules work. And I think it's pretty much it. Just enjoy and let us remember to respect each other.
Yes.
And healthily listen to all the awesome talks.
Yeah. So just to add, and I would like to reinforce that point. Let's respect each other during this event, and not just during this event, but always, but especially we have to say it today. And I would like to just make another point here is so it's been just Lucas and I speaking so far, and so Eva is not speaking because she doesn't speak English, so it's like she's feeling ashamed, like since she will not be able to say anything. But she wanted me to translate this to you, and to say that she's very excited with the conference, and terrified as well, like we were saying, right? We were like shaking before starting. And so yeah, and another thing that I would like to point out is something we're trying always to do our best here, and but not it's not always possible, right? So for instance, something that shame me, or something that I'm not happy with this conference, and I would like to change it in the next one, is is the fact that we only have a woman, right? So we only have Emmelyn speaking today, and for 8 minutes, I think. So that needs to be changed. We're now trying to partner with Women Who Code and other initiatives like Women in API Days, or I think it's Women in API. So yeah, we need to change that, right? Because it's amazing that we reached a lot of people, really good people, and we couldn't reach to many women. It's not that we didn't accept their talks; it's that we only had one submission, and it's the one from Emmelyn, right? So yeah, we need to definitely change that. On the positive side, I think it's we're about to start, right? Let me just tell you how this is working behind the scenes. So we have a script with all the timing, and we're being fast. We counted like 9 minutes, and it's only 7 minutes since we started. So let's dedicate a little bit more time to our first speaker, maybe. And let me introduce Paul Taylor, as he's strategic advisor for MuleSoft. Paul, can you probably jump in and say hello?
Hey, hello from Sydney. It's great to be here today.
Okay, so so Paul, can you tell us a little bit what you're gonna talk about today?
Sure. So my talk today is very much around my experience of supporting events at scale and the trouble that you can sometimes have, and looking at some of the patterns and use cases I've managed to implement to try and get around those to keep the business running.
Awesome. So that sounds like super exciting to me, because when I first read your proposal, it was like, I love it, because people usually talk about the cool, the cool stuff, the cool things, the things going well, the happy path always, right? But when I saw your proposal, it was like the unhappy path, and it's like, yes, let's start the conference with the negative side of things, right? But
I did worry about that. It's like, okay, I like this. Don't take all the negatives.
Yeah. But it's actually like it's not like the negative. It's not just that that was a joke, right? But it's actually positive that we talk about the unhappy path, right? So we make each other better, right? It's not just speaking about all the cool stuff that we can do with technology, right? It's good to it's always good to give this vision, right? From the the unhappy path itself. Cool. So not gonna entertain you more. So right now we're gonna put the video from Paul, and again, Paul will be there, so he will be answering questions in chat. And yeah, enjoy the talk.
Good morning, good afternoon, and if you're here in the lower part of the Southern Hemisphere like me, good evening. I'm Paul Taylor, a strategic advisor with MuleSoft, and it's my absolute pleasure to have the opportunity to talk to you at the first AsyncAPI conference, for which the AsyncAPI community should be commended on putting together in such a short space of time, and of course making the event both virtual and free. The subject of my talk today is the unhappy path and dealing with bad events, although I guess the subtitle here could have been Things I Wish I'd Known Before Implementing Event-Driven Architecture at Scale. I should also add the lessons learned here weren't on every project. I'm not sure that would reflect too well on my abilities to design and implement, but I'm more the product of a long and varied career, and hopefully the points I will cover could save you some time and pain in the future. So a word on the content I plan to present. It's really aimed to provide some pointers to meet the business requirements you're trying to meet with your event-based technology stack. First, I'm assuming you do have business requirements, right? I mean, no one in IT would implement technologies because it's new, cool, and shining, would they? But anyway, the serious point I want to make here is to implement asynchronous patterns well takes hard work. If your requirements could be met with REST, request response patterns, do that. The unhappy paths are a hell of a lot easier to deal with for synchronous flows when you can send the response back to the consumer than they are for asynchronous, where you have many decisions to make how to handle failures. I should also be clear on what unhappy paths and bad events are, mainly because they're the focus of this talk and it would be good to level set. An unhappy path is the flow you take when an unexpected error or failure occurs, i.e. not the normal happy flow. And bad events, well, they're just that. Events that cause problem, either due to their format or content, or just bad timing when they were meant to be processed. I guess to give you some background on me, I should say I try to take life not too seriously. And in keeping with the immortal lines from Monty Python, worse things happen at sea. So keep that in mind during the following presentation. I want to start by talking about an event, its shape, its size, and its intent. Though before I do, if anyone's watching is in charge of an enterprise canonical data model, firstly, you have my sympathy, and second and most importantly, I should point out that all views in this presentation are my own, not my employer. So if I upset you with any of my statements about data modeling, I will apologize now. If you haven't come across an enterprise canonical data model before, they can be huge beasts and try to capture and define data across all use cases in the enterprise. This means they can sometimes be a little unwieldy to work with, to say the least. And although at a logical level, you can see the benefits, trying to directly implement that in full can be an issue. Now, I must admit my bias against large-scale enterprise data models stems from working on projects where it was an unbreakable design principle that the canonical data model had to be used for all interactions. Now, trying to get a large data model to play nice with bandwidth-limited devices was a major issue, to be honest. And in fact, that unbreakable design principle had to bend, shall we say, just a little. But anyway, that's my thoughts on that. So drilling down on an event, what should an event contain to be most useful? Yes, the core is the significant event or state change, but is that it? My point of view on this is, as a good corporate citizen or even netizen, you need to give some thought on the value of the event you are producing and how you can increase the value of it and help others realize that value. Make it too hard to use and the ROI doesn't make sense. You're going to struggle to get traction. Of course, not all events are equal in value and the associated care that you can subsequently give them. The reality is that some events are even disposable. However, the first point I'd like to make, and it may seem obvious, but is make your events specific, not generic. We often try to make things reusable, but going down this generic path means you end up sometimes overcomplicating or having to constantly enrich what you're trying to achieve with additional metadata for the event to be understood. Or worse, you end up doing both, overcomplicating and over-enriching. So, as an example, if a customer updates an address, does an address update event make more sense for you than a generic custom update event, which of course could include a whole host of different updates. It could be, their telephone number, their email address, their name change. For me, it's the former that is often the best practice, where you have that specific event. So once you've decided on the event, you need to think about the event envelope. What additional data does it make sense to include beyond the captured state change? Do you need to include some time-dependent data along with that change? Maybe given the context of the change, i.e. the change was set in motion by a condition being met, or was an event generated by a third party? Maybe it required authorization. The auditing and governance team would thank you for that being part of the append-only event stream, because it gives them that source of truth. This can also hold true for channel information. Was this via a mobile channel or web app, maybe? Thinking about what you can enrich an event with, reference data can often be useful. Is there a requirement for each and every subscriber to that event to end up doing the same lookup to obtain some piece of reference data? would it make sense to actually inject that into the event at the time it's produced? Also, you need to think beyond the initial play of that event. Is there a chance that this event may end up going down a happy path? Will the event contain enough information for you to replay that event in the future? Is it the right shape to support the future requirements? Now, I'm not talking about populating the whole enterprise canonical data model in the event. Very few consumers would thank you for that, not to mention the infrastructure network and security teams. Be pragmatic with the event design. I think history has taught us religious wars never turn out well, and the same can be said for event modeling. My advice would be passionate with your point of view, maintain design principles, but stay pragmatic. Keep in mind those non-functionals when designing the events. Governance, auditing, load handling, they all need to be considered as the wider implementation. And as I said, can you handle the unhappy path with that event when it's replayed in the future? Now, it may be that version 1 of your event definition has to change over time. That's of course okay. It means you have traction. But just as you no doubt do with your REST API designs currently, tread carefully with those breaking changes. Now, I fully expect AsyncAPI to help here, as more and more tooling supports it, allowing events to be designed, understood, and consumed in a consistent way. I want to discuss ordering, and even if you don't have a need now, I would expect at some point on your event-driven architecture journey, you're going to come across event ordering and the need to maintain it. Of course, plenty of use cases don't require strict ordering, but it's not difficult to think of those that do. Banking and insurance, and you could say even more importantly, especially in these times, healthcare. They're all obvious use cases that require the strict ordering of events. Ordering of course, sounds easy, especially when you have an append-only log. But how do you maintain that order down through the consuming network? You may, as example, have systems of record that still run on big iron in the back office that will refuse to update unless state changes are received in a certain ordered sequence. Let's take an insurance use case and the events associated with that. You raise a claim, but you can't pay a claim until the claim has been accessed. So these events in the claim process need to be ordered. So what's the issue with ordering? Well, first, let's look at the simplest way to maintain order and the pitfalls you may come across. If we have an ordered event stream or associated broker that maintains order for us, and we subscribe with a single consumer for all updates, then making sure each event is consumed and processed before moving on to the next. In essence, we've created an end-to-end single-threaded flow for the normal happy path. We can ensure ordering is maintained. Pretty straightforward. But the problem with this approach aren't difficult to see. For a start, scalability. You can only consume events as fast as a single-threaded, single consumer can process them. For low volume, that might not be a problem. But what if the new widget service you introduce just goes viral? You may find the producer creates events far quicker than you can process with this architecture. This would give you an ever-growing backlog, and we all know scaling vertically has its limits. So there's only so much you can do with a single consumer. Also, resilience. Single consumer is a single failure point. So maybe you need to introduce an active-passive configuration. Now, hopefully that will help you avoid downtime, but it doesn't increase throughput. So we still have a scalability issue. Second, what happens if you have a problem with certain events? These are the bad events I mentioned earlier. i.e., let's say there are data issues with the event or a downstream platform refuses to process it due to stale state being stored. What do? Stall the event stream consumer, page the operations team, wait until someone comes along and fixes the events manually and restarts the consumer? It's actually how it's handled more commonly than you would think. But to be honest, it's usually a less than optimum solution and can lead to a lot of upset stakeholders in a pretty short space of time, especially if you bring the business to a standstill while the issue is sorted. So what are some of the techniques to mitigate against these? Well, if you need more throughput that can be achieved with a single consumer, you of course first need multiple live consumers. Makes sense, right? And an identifier to correlate related events. For example, this could be the account ID or policy number. Without that, you may be purely aggregating events. So order doesn't really matter if you're aggregating, obviously. Then you need a way to ensure that those for a single entity are grouped for consumption to ensure the order is maintained end to end. You can do this either on storage by storing into different partitions, which then have dedicated brokers, or use a broker that hides in-flight events based on the same identity. So if you do have those multiple brokers and 3 updates in an event stream for account number 42, for example, when the first of those is consumed, the other consumers are shielded from knowing the other 2 updates exist until that first event has completed. Okay, so now we have multiple consumers, so we can get the throughput we need, and we've got resilience and still retain ordering. That's all great. But what about when events get stuck? i.e. the system of record for account number 42 is locked and won't accept any updates for that account. You see the problem. Are we back to stalling consumers and having the business upset with us? Well, this is where it actually gets interesting as far as ordering is concerned. And we need to introduce a dead letter queue, but more on that later when we take a deep dive into DLQs. Okay, so often we need to consider what happened when and why. So turning to event observability. One of the big problems when ending up down the unhappy path is understanding how you got there in the first place. And also, usually you have to reach the understanding pretty quickly, especially where you have a pressing production issue to deal with. It's very frustrating when you have to rely on a manual log gathering process, and then after a lot of effort, trawling through the logs to still only to get an answer hours or days after the issue. I generally refer to this as log archaeology. It's not fun, it's tedious, and it takes time. And if you're under pressure, it makes it even more enjoyable. Even worse though is when you don't have the correct logging in place and need to turn up the debug log and then just wait for it to go wrong again. You generally don't win friends with that. Ideally, you want to have as much visibility as possible. And of course, enterprise login and visualization platforms are available, such as Elk or Splunk, etc. And they can go some way to helping if implemented across each layer in the enterprise. A key point, of course, is you need a correlation ID of some type, either in the payload or header, to tie together events as they flow through the infrastructure. The end-to-end observability of events becomes a key weapon in resolving unhappy path or bad event issues. The question does get raised as to what does end-to-end practically mean. For example, do you have the ability to observe the event producers? Can you observe the consumers that may fall to the system of record? And again, can you observe the system of record? Given that many enterprises have a varied mix and age of technologies, applications, and platforms, rarely can you get a complete unified end-to-end view. If you can't go end-to-end, can you at least ensure that the brokers and associated consumers are at least observable, i.e. observe in the middle? That's a lot better than nothing. Also, when building out the observability, give some thought to spawned events. That is events caused by other events. Do you have a way to link these together? Doing that is incredibly powerful in the end-to-end issue hunt. You will find various tracing frameworks that were developed by industry powerhouses such as Facebook and Google. These are very useful in helping you work through your problems. Even if you don't use the actual framework, they can certainly seed ideas. Now, let's talk about a feedback loop. Even in the age of cloud, elastic scaling, and platform size to handle internet load events, applying a break, or as it's commonly known, back pressure via feedback loop, may seem unnecessary, especially with the event-driven architecture. The consumers can just consume at the level they're comfortable with, right? Well, maybe if you have a greenfield site and no legacy, you can implement true decoupling across all platforms, and back pressure then may seem like a legacy thinking. But certainly I've found that in the greenfield sites, there always seems to be a platform or maybe a SaaS product that can't consistently drink from the fire hose. They sometimes creak under the strain, especially when the events are actually being pushed to them via some middleware rather than being directly consumed. Reacting and implementing support for the back pressure pattern is often implemented in the integration platform. So for example, MuleSoft, obviously example on where to do this, where you can actually understand the feedback from the consumer or target system. To use back pressure, you implement a mechanism indicating that the receiver or subscriber is unable or unwilling to continue with the current applied load. This can be done by the downstream system in various ways, depending on the event transport being used. And as an example, using HTTP, returning a 503 status code on some of the requests, that being service unavailable, is often used to push back on incoming requests. Limiting the consumer concurrent threads is a useful way to limit the impact on the system under stress. Or you can also rate limit by throttling the transaction per second count, i.e. how quickly are you pushing those events down to the platform. Keep in mind that, because you've got cloud-based elastic infrastructure, you can usually just keep scaling. That's great, but you won't be thanked for reducing a system of record to a deadlocked mess by spinning up numerous cloud instances. You need to think of the bigger picture and the overall impact of the enterprise. Just moving bottleneck from one location to the other doesn't actually increase your end-to-end throughput. Now, a topic which always generates debate. Coupling is really a fun architectural issue, and tight coupling is the root of all evil, right? How often have you heard that? I bet in that or some kind of variation, it's been a lot. But we're talking about event-driven architecture. So what does tight coupling even mean with an architecture by design that's meant to be decoupled? Well, for me, in the end-to-end architecture, it can actually mean many things. It could mean consumers bound to a large set of event attributes, making changes and versioning of your events difficult. Or maybe you've got some kind of complex orchestration of events with hard dependencies between them, i.e. event 1 has to finish and it has some relationship with event 2, and you could end up in some kind of infinite loop. That's all kind of hard dependencies you want to avoid. But the one I want to talk to you about now is the coupling of system availability. Most of us expect services to be available when we want them at our convenience, not at the convenience of others or the companies we deal with. I know from experience, a surprising number of people want to pay their bills or check balances at 3 a.m. in the morning. Don't ask me why, I just know they do. Giving the customer what they want means system availability needs to be 24/7. And if you don't offer that, your competitors will. But the reality is many established enterprises still run back office systems that need regular maintenance windows. Well, for real-time query operations, you can, of course, fall back to reduced functionality or use cache data and provide that back to the client while the system of record has downtime. And using a pattern like CQRS, that is Command Query Response Resegregation, can help here by having clear paths to handle both the read and the write. Using events, of course, we can decouple those write operations or state changes and then wait till the system record is available before having them consumed. A note of caution here, you need to make sure that it's clearly communicated that this pattern is implemented and try to ensure that client applications don't make assumptions on when state changes will be available. So this may mean moving towards a mindset of eventual consistency rather than distributed transaction type of implementation, which traditional enterprises may be more familiar with. You also need to understand how long any schedule outage window is going to be. You don't want to end up with a backlog of events that you're then going to struggle to clear when normal service has been resumed. Right, I'm now going to bring us back to the topic of ordering, one of my favorites. And this time in relation to a dead letter queue. I should point out, when talking about a dead letter queue or DLQ as I refer to it, it's not available with all technologies, at least out of the box, although conceptually you can normally implement something similar. We'll just go with the generic definition for here to make a point. Generally, the dead letter queue, if you haven't come across one before, can be used by a broker or consumer to store events that can't be processed, for example, due to a data error, event envelope, or maybe it's a plain old business logic error. There's usually a retriable parameter that you can set to control the number of attempts that it will try to process that event before it's moved to the DL queue. And that's done so that you can handle transient type errors. So for example, a system of record maybe you have a HTTP timeout, but next time around it works. You don't want to necessarily fail those events straight away. So when you do hit an error though, it will move the event to the DL queue, and that can unblock a bottleneck and allow later events to be picked up for processing. But when you're trying to process events in order, it now of course gives us an ordering problem. We take our example from earlier, but now use DL queue. Let's assume we have a problem with event 1 for account 42. We can move that event to the dead letter queue. But what do we do now with events 2 and 3 for that same account? Without thought on our part, the default behavior is usually events 2 and 3 are ready to be consumed as soon as event 1 is moved. And we then propagate out of order events across the enterprise. You know, exactly what we were trying to avoid. Now, given that most, if not all, DL queues are actually a generic queue or partition that has just been designated to be DL queue, it actually works exactly the same as the original event store as regards ordering. So how do we handle this? Well, one way is to have the consumer check if any pending failures exist for the event identity, i.e. does account 42 have an event in the DL queue? Now, if it isn't possible for you to directly query against the DL queue data store, for example, your DL queue might not support a search type operation, you may need to maintain an external operational database that can be used to track failures, updated each time you have a failure and removed when it's completed. And that will give you an idea if there are any pending failures that exist. If there are, what do we need to do? We need to move the subsequent events and quarantine them, just like us, place event 2 and 3 into quarantine in the DL queue to ensure they're not processed out of order. You may have some corrective maintenance done. Someone may have to come and look at the events, figure out what they're going to do, move them back once they've been fixed, or maybe delete them if that's the appropriate course of action. It's not pretty, but it helps automate as much as possible the failing events. And of course, it's really preferable to only have to deal with one affected customer rather than have all customers being blocked. A tip, of course, is to have some kind of alerting set up for the DL queue. Monitor its depth. It can be a good early warning sign of problems and good to give the relevant stakeholders a heads up of any potential problems. One of the characteristics of high levels of automation is when things go wrong, they can go wrong at tremendous speed. Before you know it, you can have a big steaming pile of issues to resolve. Catching these early can be a challenge, especially if the failure is subtle. One example of this I came across was when a downstream process to send out communications to customers, emails in fact, had a failure in send. The problem was it interpreted the send failure as a bounce back and had been configured to mark the customer email address as invalid. And in such a case, it started to update all of the customer records to reflect this. And I'm talking about millions of customer records. The first sign that we had that something was wrong was the number of events causing writebacks to the system of record went through the roof. In fact, the operations team remarked in passing how well the cloud infrastructure was holding up under the load. So here we have a valid producer creating conformant events, but just making incorrect assumptions. Now, given this scenario, catching these type of issues can be difficult. They could be viewed as edge cases, and each type of failure like this may be different, so difficult to code in advance. The best way I've come up to handle this issue, but if you've already solved it in a better way, please let me know. I'd be interested to hear, was monitoring of the event load. If a sudden large increase of usually fairly predictable events were seen, it would trip a safety valve and stall the consumer until someone could come and eyeball the actual event, see what was going on, make a reasoned decision on whether they should restart that and carry on. Of course, in the meantime, all events would be installed, but they were just not being propagated on. Actually, to fix the impact of this email issue I mentioned, we had to do a mass replay once we figured out what the problem was. But this time flipping the email invalid flag back to its correct value. Otherwise, no one would have got emails, which you may think was a good thing, but the company in question certainly didn't. What I found was funny, though, was how something like this shows the value of event-driven architecture to a wider audience. Without being able to replay, each system of record incorrectly would have had to done a restore, either from backups or go and write jobs that sweep the database and make updates, needing to figure out the logic to tease out which had been invalid updates and which had actually been correctly updated previously in the past. It would have been a mess, and it would have taken a long time to sort out. Because in this case, and in general, the systems of record, which there were many of them, relied on traditional related databases as a store of truth. So they only stored the latest update. They didn't have a history of updates. So a point to keep in mind, depending on what you're trying to resolve, is you might not be able to do a straight replay. Though if you can get away with that, it's usually straightforward, as you can set the consumer back to the event you wish to start from and then just let it roll forward. If that doesn't fly for you, you may have to do some data transformation on the fly, just as we did. So fun times and not much sleep that night, but the business was up and running next day, and I'm pretty sure complaining about something else. It's, you know, pretty surprising how soon people forget. Okay, that's my story. But I wanted to wrap up with a few points. First, let me be clear. The point of my talk wasn't don't do events or event-driven architecture or don't use AsyncAPI. I'm a big fan. It's more, look out for the issues we've just reviewed, and if you come across them, then hopefully will this help you navigate them and do events well. If not the first time, maybe at least with version 2 of your implementation. I have found that within reason, memories fade on how long it took to deliver something, but production issues, they're more of a constant headache, so do all you can to avoid those. Remember, you know, as much as I like events, events aren't a cure-all. They're just another tool in your toolbox. Don't get tempted to use them for every use case. Does a request response implementation also make sense? These things need to be considered. Help yourself by helping others. Use AsyncAPI to convey the details and intent of the events you're dealing with. This lowers both the barrier to entry, speeds development, and helps with the event self-serve, i.e. teach them to fish. Try to design failure handling into your environment early in the process. It's much easier to think about the best way to handle those at the design stage, not at 2 a.m. when you're trying to get a very upset stakeholder back online. And of course, in a world where toilet paper seems to take on special value when we're dealing with a virus that, as far as I know, affects breathing and temperature, though I'm not a doctor, I guess you need to always expect the unexpected. Well, I hope you enjoyed my talk and found something of interest that may help you in the future. Beyond the Q&A today, if you'd like to discuss further or just connect, you can find me on LinkedIn. I hope you enjoy the rest of the talk scheduled today. I know I'm looking forward to them, and I hope to speak to you again, maybe even as part of the AsyncAPI community. So thank you, and thank you to the AsyncAPI community for bringing this day together. Goodbye.
Okay, folks, so we're live again. Thanks, Paul, for this amazing presentation that you gave us today here. And thanks for joining us from Sydney, which we know it's so late right now. So we have just 1 minute left if in case you want to say something or you want to answer some questions that's on top of your head or something.
Sure. So firstly, thank you for the opportunity. And yeah, it's not too late yet. Thank you for giving me the first slot. If it was 3 a.m., then that would be too late, but that's fine. I will answer the questions in the chat channel as we go. Unfortunately, I speak faster than I type. So I will answer them over the next few minutes before the next talk starts. I think we've got a 5-minute break. So I'll get through around answering those. And as I said, on the end of the talk, you can always reach out to me on LinkedIn if you want to continue the conversation, and we can take it from there.
Awesome. Thanks for joining us today. So next up, it's going to be Abel Gómez from Barcelona. And we're going to take a little break from the live stream, and so we can show some images from the sponsors, which we are very glad to have them on board. And yeah, so you can have some time for you as well. See you back in a few minutes. Okay, folks. So we're going live again, and we just saw a few slides from the sponsors that I would like to mention that we're so happy to have them on board. And next talk is from Abel Gómez. Is to me is like it's a special one, right? Is one the talk coming from Barcelona, right? So it's like it's amazing that we have someone from Barcelona, right? So Abel Gómez is a postdoctoral researcher on the Internet Interdisciplinary Institute on the Universitat Oberta de Catalunya. And he's going to be speaking about a model-based AsyncAPI code generator for IoT environments. Enjoy.
Hello, everybody. Welcome to my talk about our AsyncAPI-based code generator for IoT environments called AsyncAPI Toolkit. Before going into the details of our tool, let me explain you first in which context we decided to build this toolkit and what kind of problems we are trying to solve. As we already know, nowadays there are more and more devices whose hardware and software are inherently intertwined. These are the so-called cyber-physical systems. these cyber-physical systems play an important role in the Internet of Things, or IoT. IoT advocates for the connection of everyday objects to the Internet, resulting in complex architectures of interrelated computing devices with the ability to share data among them without requiring human interaction. But most of the times, these devices do not have high computing or storage capabilities, and most of the data they acquire is sent over the Internet to other devices or services which can store, process, or analyze them. Given these limitations, typically these architectures follow a publish-subscribe approach, where devices or services interested in a specific topic subscribe to it. When a cyber-physical system produces information on that topic, it is published, and a broker is then in charge of delivering it to the interested parties. But although these kind of architectures are very scalable and fault-tolerant, they are not completely problem-free. Due to its distributed nature, it is really hard to maintain consistency. Consistency problems mostly appear in two forms. First, devices in the network may publish or subscribe to the wrong topics, thus not delivering or not receiving important information. And second, there can be deviations in the message format. As a consequence, a subscriber may receive information in a way it is not prepared to parse, thus losing information or even causing runtime errors or crashes. One way to alleviate this problem is to have a single source of truth in our architecture. This single source of truth will contain all the information to run our infrastructure. Examples of such information are the addresses of the different hosts providing core services, which are the topics that can be published or subscribed in the architecture, or even which is the exact format of the messages that can be shared among peers. And here, as we all know, is where AsyncAPI emerges as the perfect solution that can serve as the basis to specify this single source of truth. AsyncAPI provides us with a specification to define all this needed information and more. However, at the moment we face this problem, AsyncAPI was still on its first versions, and there was still a lack of tool support for the specification. So we decided to contribute to the community an open source tool to automatically generate code based on AsyncAPI specifications. For this, and based on our experience on model-driven engineering, we use the Eclipse IDE and the Xtext framework. For those who don't know Xtext is a framework for the development of domain-specific languages. With Xtext, you define your language using a grammar language, and as a result, you get a full infrastructure, including parser, linker, type checker, compiler, as well as editing support for Eclipse. And we call our tool AsyncAPI Toolkit. This figure shows how our tool was designed and its main working principle. First, and based on the AsyncAPI specification, we manually created an Xtext grammar for it. Based on this grammar, the Xtext framework is able to obtain a metamodel of the language. From this metamodel, the Xtext framework generates all the infrastructure that gives support for AsyncAPI. We specified our code generators taking advantage of all the infrastructure that was generated by Xtext. When a developer wants to generate the code for a specification, the only thing he or she has to do is to code it in the provided AsyncAPI editor. A model of the AsyncAPI is automatically created from this textual specification, and also automatically the final code supporting your API is generated in the IDE. So now let's see what the tool looks like, and let's play a bit with it. The first thing you have to do to use our tool is to just install it on top of a clean Eclipse installation. So you only need to get the URL from our GitHub repository, copy it, and install it. Now here I have already an Eclipse with everything installed, but the only thing, as I said, is just to go to install new software, paste here the URL, and everything will be installed. The easiest way to start using our tool is just use the new project wizard. So going to the AsyncAPI project, you have several templates. You can choose to create your new API specification. You can start by an empty AsyncAPI project, but first I will use an example of the streetlights example that we can find in the AsyncAPI site. So when a new project is created, basically what we obtain is an example Java file with the main method and the file with the specification and the folder where all the source code is automatically generated. This is the Streetlights API. So here we see that we have the specification of the name of the API, a set of servers. In this case, I forgot to launch the broker, so I will launch the broker for the rest of the demo. And also we have a list of topics. These are the topics that are the different channels that have been specified in our API. Here, for example, we have this topic, the lighting / measure that has this street light ID parameter, and we have here the operations for the publish and subscribe. We see here that the message that is published or to which we subscribe is this light measure that is specified here below. This light measure message, and here we have the link to the payload, that is this payload here. The payload, it's an object with a Lumens property, which is an iter and a send that here we specify that it's a string. So we see that from this specification, we have this generated code. For example, if we see the lightning measure topic, we have a package for it with the classes for the publish and for the subscribe operation. If we look at the publish measured class, we see here that we have the methods for publishing. Here, for example, for the subscribe, we have the methods for subscribing. And we also see in the publish that we can pass a payload, that it's this light measured payload, that it's specified in the schemas package, which is this class here, light measure. Here we have the methods to get the information from a payload, and we also have this builder that implements a Fluent API for creating new instances of the payload. So let's see what the generated code or how the generated code is used. For this, we have this main example class, which is the main class. First, here we have the method for subscribing. So here we have the lambda that receives as parameters the parameters of the message and the message itself. So here we see that once we receive the message, we can directly get the lumens from the object and the send tag. So when we receive a new message, the only thing we do is just printing on the standard error the information about the message. And here we have the code that creates the payloads and finally sends here in the publishes this message. So as we can see in the payload builder, from the message class, we can obtain a builder, and directly with this builder, we can start setting the information. For example, using the method with lumens, setting it at 10, with send tag, we specify the local date time, etc. So when we publish it, this is sent to the broker and it's delivered and it's received in this subscribe method. We can directly run this code. So run it as a Java application. Here we have the console, and here, after running it, we see that we have been publishing this first message with lumens 10, this second message, okay? And this is the message that we have printed once we have received it. We also can see here that those messages passed by the broker. And the point of having this generated code and all this API is that we can detect if errors are introduced or in the code, or for example, when we change in the specification something. For example, if we go to a Streetlights API, if we go to the send tag and we decide that, for example, that the send tag is no longer a string, but maybe it's an integer, okay. When we save the code, automatically we have changed the method for setting this property of the message. So now we see that, for example, we are receiving an error with send that, because it is no longer expecting an integer, but it's an string, but it's expecting an integer. So maybe this is because we are going to send here the epoch time. So if we change this, this will work again. Well, in this case, since this method returns a long, we will cast it to integer because, well, in JSON we cannot specify longs. But in this case, if we run the code again, we see that everything is working. And we are sending an integer and we are receiving an integer. This is not the only way we can use for creating some code. We can also start from a model of the data we want to send. So for example, if we go to the AsyncAPI project, we have some other wizards. And in this case, we can select this example, that it's creating a project from an ICOR file. So here we see that together with the AsyncAPI specification, we have this ICOR file. I'm going to open it graphically. Basically, what we have done here is just to specify which are the complex data that we are going to send in the messages. For example, here we have one sensor with a name that contains a set of events that are of an enumerated type, and these events contain a timestamp. In this case, it's important to see that the sensor can contain any number of events. So when we have complex data models, we can model them, and by annotating some information, for example, we can see the sensor here and go to the properties. We see that we have some annotations, and here we see that this is the information for specifying a channel whose name is sensor/events, and we provide two operations, publish operation and subscribe operation. So from this, we have automatically obtained this AsyncAPI specification. And here also have some example code that we can see is basically the same or very similar to the one we have just seen. But in this case, for example, we can see that since we can add many events, so we have a method to create the events and to add them. So for example, we can add several events. Oh, sorry, I moved this wrong place. Okay. So now this can be executed and runs perfectly like the other example. So here we see that the messages are sent and everything is working fine. Well, that's all. Here you have the link to our tool, to our repository. So feel free to download it, test it, leave your comments. Thanks for watching and listening, and thank you very much.
After the break, we're live again, and with us is Abel. So first of all, thank you, Abel, for recording this session for us, and congrats. It's a really rare situation that you see a live coding works without issues in the presentation. So we have less than a minute before the break. Do you want to say something, Abel?
Well, I just want to thank you for the opportunity and for showing this prototype. So the only thing is, well, in the presentation, they have the link to the tool. And so we will be happy to, if people test the tool and send any questions or comments or anything to us via our webpage. So that's all. Thank you. Thank you for listening, and congratulations for the conference.
Thanks, man. So we're going to have a short break again now to show the logos of our awesome sponsors. And yeah, wait for the next live. So I'm here to introduce the next talk, which is from Kévin Dunglas. And the talk is about building async public APIs with HTTP2 and the Mercure protocol. And I'm personally very much interested with this talk, and especially work done by Kévin, because his Volcanic project is pretty interesting, especially for me, a fan of GraphQL. So yeah, enjoy the presentation.
Hi, everybody. Today, I will speak about the Mercure protocol. Mercure is a brand new protocol to build async APIs that will be consumed by web browsers and mobile apps. My name is Kévin Dunglas, and sorry for my terrible accent, but I come from France. I'm the founder of the company Letilleul.coop. I'm the creator of this protocol, Mercure, but also of a few other things, including the Vulkan protocol. It's a new protocol that aims to replace GraphQL, more or less. The API platform framework, it's an open source framework to build web APIs that is very, very easy to use. And I'm also a maintainer of the Symfony PHP framework. You can follow me on the social networks by using my last name, Dunglas, as handle. So, Letilleul.coop, it means the lime tree.cooperative in English. It's a special company because this company is entirely owned by its employees. And all the decisions we made are made democratically. We are providing professional services and we do consultancy. So if you want to build nice web APIs or nice async APIs, if you want some help to build projects using Symfony, PHP, API platform, but also Go, Kubernetes, Apache Kafka, drop us a mail. We can do that, and we will do that very well. So if you are here, I think that you already know what AsyncAPI and real-time APIs are. Most of the times, async APIs are used for server-to-server communication. For instance, you will use Apache Kafka or RabbitMQ to send messages to different services in your information system. But it can be very useful to create async APIs that will be consumed by mobile apps and web browsers too. So it's a different topic because the messages will be sent over the internet. So you have the constraints. We will see that in a few minutes. But for instance, you can see in this video an async API being used, an async API built using the Mercure protocol, being used with a typical REST API. In this example, every time someone is connected to a web page, he can push on a button to dispatch, to broadcast an emoji to all the other connected devices that are on the same page. To do that, we need the server to push the data to the client. I mean that first, there is a post request from the first device to the server. The server stores the action that has been done, and then the server must push the data, the new action, to all the connected devices. And the Mercure protocol allows to do that very easy. Do we need a new protocol to do that? Actually, if the client is a web browser, you cannot use directly UDP or TCP to connect to the server. The web browsers have limited capabilities for security reasons, mostly. And if the client runs in a web browser, then you have to use HTTP. So at the beginning of the web, at least, the only way you have to fetch data from the server and to let the server tell the client that there is something new, it was polling. So when you use polling, you just create a URL on your server, and in JavaScript, you create a timer. And from time to time, you will send a request to the server to check if there is something new. This is not a very good solution because you will consume a lot of resources server side for nothing, because most of the call will be done while there is nothing new, and it will be useless. And the other big drawback of this approach is that it's not true real time. You will have to wait for the timer to be finished to check if there is something new. So it can be a large latency, it can be a huge delay. So it's not a very, very good solution. There is another well-known solution that is a more recent solution. It's WebSocket. So WebSocket is not the HTTP protocol. How does it work? Basically, the client will create an HTTP connection to the web server. And then the client, using a specific HTTP header, will ask the server to upgrade the connection to another protocol that is not HTTP, but that is WebSocket. This protocol is interesting, but has a lot of drawbacks, and we will see that in the next slide. It has an interesting capability, is that it's a full duplex protocol. It means that the server can push data to the client, and the client can send data to the server too. And finally, we have a third option, and that's all. It's the event source protocol, the server sent events. This tiny protocol is built on top of HTTP, but it fixes the problem of the XHR polling strategy. Basically, the client will create an HTTP connection to the server, but this connection will stay open forever. And in this persistent connection, the server will be able to push some messages in this tiny protocol to the client. And when a message will be pushed by the server to the client, a JavaScript callback will be triggered by the web browser, because web browsers have native support for this protocol. This protocol is not a full duplex protocol. Only the server can push data to the client. So let's compare WebSocket and server-sent events. WebSocket has some benefits over server-sent events. First, it's a full duplex communication protocol. And another benefit is that it's a lower level protocol, so you can control exactly what is over the wire. But WebSocket also has a lot of drawbacks over server-sent events. Its first big problem is that it's a low-level protocol. So it's a benefit and it's a drawback. Why? Because server-sent events has a lot of native capabilities that are very interesting. For instance, because it is built on top of HTTP, it has authorization support, so you can use cookies, you can use the authorization header. It will work because it's built on top of HTTP. With WebSocket, there is nothing like that. If you want this kind of control, you will have to do that by yourself. There is support for reconnection. It means that if for some reason there is a network failure and the connection is closed, then the browser will automatically try to reconnect to the server when using server-sent events. With WebSocket, you will have to do that by yourself. There is a state reconciliation mechanism built right into the server-sent event protocol. It means that if there is a network failure and that some messages are lost, then the browser will keep in memory the ID of the last message it has, and when the network will be back, it will send to the server the ID of the last message it has, and the server will reply with all the missed messages. With WebSocket, if you want something like that, you have to build that by yourself. And finally, server-sent event has a native history of all the events that have been sent, and you can ask for past events. It's something that is not available in the WebSocket protocol. There is another big problem for modern applications, at least with WebSocket, is that WebSocket has been obsoleted by the HTTP2 protocol. So the rationale being that is that HTTP2 is a full revamp of the HTTP protocol, and now it has natively the capabilities to let the server push some data to the client. So we don't need another obscure protocol along with HTTP. We can just use plain old HTTP2 at least, to send data in both ways. So until very recently, no browsers were able to use WebSocket when using an HTTP2 connections, and still now, Firefox is not able to use WebSocket if the connection is using HTTP2. It's by design, because if you use HTTP2, you don't need WebSocket anymore. HTTP2 has capabilities similar to WebSocket built in. And finally, WebSocket is hard to secure. It doesn't respect the sandbox and the security measures of web browsers. For instance, CORS aren't respected by WebSocket. It's a lower level protocol, and it's very hard to secure. For instance, one of the most dangerous security vulnerability found in Kubernetes last year was because they weren't able to secure properly their WebSocket implementation, and they are the Kubernetes team. There is a common issue when using WebSocket and server-sent event. It's that both rely on persistent connections. So if you use serverless platforms, such as AWS Lambda, or if you use PHP or fast CGI scripts or things like that, in most platforms, there is a timeout for a connection. Here, with both protocols, the connection must be a persistent one. So it's a small issue, but with some stacks, it can be a problem, a big problem anyway. For persistent, long-lived connections, it's better to use a dedicated software and dedicated hardware instead of polluting your application server with this kind of tasks that are very specific. So let's introduce the Mercure protocol. The Mercure protocol aims to fix most of these issues, both in WebSocket and in server-sent events. So, Mercure, it's mostly two things. First, it's a specification describing the protocol. And there is a reference implementation that is written in Go, that is a free and open source software that you can use in your own information systems to create AsyncAPI using the Mercure protocol. Both can be found on the Mercure.works website and the Mercure repository on GitHub. Mercure is a very high-level protocol that is built on top of both HTTP and server-sent events. Because of that, it's a full duplex protocol. To send data, you will use a post request. So for instance, if a client wants to push some data to the server, it will use a post request, a plain old HTTP post request. And to receive data, the server will use the server-sent event protocol to push data to the client. Because it is built on top of server-sent events, it has support for reconnection, retrieving of lost messages, history. It has been designed to be auto-discoverable and to work mainly with REST and GraphQL APIs. So the main use case for Mercure is to add async and real-time capabilities to your existing or new REST or GraphQL APIs. It has a native authorization mechanism built on top of JWT. This mechanism allows to send private updates that are secure. It has support for serverless and PHP stacks. So it is able to handle in a proper way persistent connections without polluting your application server, without letting that to your application server. And it has native support for encryption. So a very important concept in the Mercure protocol is the hub. Basically, when you want to broadcast a message to the client, the hub will be the main component. Let's say that your application server, your PHP server, your JavaScript server that will serve your REST or GraphQL API want at some point to send some async data in real time to the clients. To do that, the server just has to send a single post request to a Mercure hub. Then, with this single post request, it's very easy. The Mercure hub will take care of dispatching and broadcasting this event to all the currently connected devices that will use server-sent events. So all the devices connect to the Mercure hub. There is persistent connections between the hub and devices. And every time a client, it can be your app server, for instance, want to broadcast a message to all the devices, it just has to send a single post request. So the concept, it's very easy. This protocol is available as an internet draft on the website of the IETF. It means that it's an open standard that you can review and improve if you want to. We want Mercure to become a RFC at some point if it is good enough. So why do we need HTTP2? Actually, we don't really need it, but it will allow to improve the performance of the protocol a lot. HTTP2 has a very nice capability that is built in called multiplexing. With HTTP1, for every single HTTP connection, you need to create a new TCP connection. It's not the case anymore with HTTP2. With HTTP2, there will be only a single TCP connection, or UDP with HTTP3, for all the HTTP requests. And all the requests and responses will be sent in parallel, thanks to the multiplexing mechanism, through this single TCP connection. It means that there are no limits anymore of HTTP connections that can be done in parallel from clients to servers. It was the case with HTTP1. That's not the case. And it means that because all the connections are in parallel in the same TCP connection, there is no overhead of creating many HTTP connections. And it's what allows Mercure to build a full duplex protocol on top of HTTP. It will work very well on top of HTTP2, especially, even if it can work with HTTP1 with some limitations. HTTP2 is already widely available. Actually, 95% of all internet users have a device that is able to speak HTTP2. So you can use HTTP2 in production right now. So you can benefit of the multiplexing and the capabilities of the Mercure protocol right now. And for the 5%, the 5 remaining percents, then you can Mercure will automatically fall back on HTTP1. So it will be less fast for it will be a bit slower, and it will have some drawbacks for the 5% still using HTTP1, but for most users, it will be faster and more secure than when using WebSocket, for instance. Server-sent event is built in most modern web browsers too. And for old browsers, there is a polyfill. So it means that even with Internet Explorer 5.5, you can use server-sent events with HTTP1, of course, but Mercure and server-sent events will work. So let's see how to use this protocol. So to publish to broadcast a message, it's very easy, it's just a single post request. So there is a specific URL, a well-known URL. It's a standard for this kind of URLs called well-known Mercure. You send the post request to this hub. You must authorize using a bearer GWT token, and there is a typo in this bearer header, but I will fix that in the slides. And you pass the topic and the data corresponding to the message right as form data. So it's very, very easy. It's a simple post with a form encoding, and the topic it's the channel in the AsyncAPI specification, and the data is the content of the update. And that's all. When you do that, your message is broadcasted by the hub to all the currently connected users. So because it's a simple HTTP request, you can do that in any existing language. For example, in this slide, we use Node.js without library. So it's just a single post request. In some languages, for instance, in PHP, there are higher level abstractions. So here we create this message. We set the topic, example.com/book/1. We set the content of the message. So here it will be some JSON. And we use the capabilities of the Symfony framework to broadcast this message. To subscribe, it's also supported right in the browser. You don't need some plugins or some software development kits. You don't need anything. You can use the event source class that is in all modern browsers. So you connect to the URL of the Mercure hub, the well-known URL, and you pass as query parameter the list of topics, the list of channels you want to subscribe to. And every time a message matching this topic will be sent, it will trigger a JavaScript callback, and you will be able to call your own JavaScript call. And for instance, in my example, I declared the JSON and I display it in the console. But for your application, you will probably use React or Vue or something like that to be notified when a new event occurs and do something with the data. You can subscribe to several topics using the same connection. Here I use the URL class that is built in most modern browsers to build the URL, and I add several topic parameters subscribing to several topics. And so every time there will be a book, a new book or a new review, my callback will be called. There is also the support for patterns using the URI topics, just as in the AsyncAPI specification. They are using URI templates for the channels names. We use URI templates in Mercure 2 for another use case. Here in this example, thanks to the bracket syntax, we say every topic matching this pattern we want to subscribe to every topics matching this pattern. So if we publish an update on the top for the topic books/1 or books/33 or any ID actually, then the JavaScript function will be triggered. So it's very convenient, for instance, to be able to detect when new data has been created, when you don't know you don't know at this point of time the ID of this new data. The discovery mechanism. So if you have an existing REST API, so as this one, you can add a link header to tell the client that if it wants to subscribe to the update for this data that has been retrieved to the API, then it can create a Mercure connection to the Mercure hub using the URL of this resource /book/1, for instance, in this example, as the topic. So it's very simple, but it's very convenient because it allows the client to auto-discover that it can subscribe to updates. The authorization mechanism. So it's built on top of GWT. And it allows to mark some messages as intended for several targets. It can be the username or the group, for instance. A publisher to publish updates must be authenticated. Subscribers can be anonymous, but must be authenticated to be able to receive private updates. It makes sense, I think. You can use for the authorization cookies or the authorization header. So, for instance, here we are in our example, we set a cookie with the GWT token containing the targets. And then, because the browsers will send the cookie when to the hub when creating the event source connection, that's all we need for the authorization mechanism. The hub will read the cookie, extract the target from the GWT, and when it will receive an update with a given target, it will broadcast it only to the users having the appropriate targets in their GWT token. The Mercure hub is written on Go, is open source, is fast, is very easy to use. You can grab it on GitHub, and to run it, it's just a single command. So you have to specify a GWT key. To run it in production, you need HTTPS, and there is built-in support for HTTPS. You just have to set your domain name and you just have to set your domain name and Let's Encrypt certificate will be automatically generated. If you are using Kubernetes, you can install a Mercure hub on your Kubernetes cluster just by typing this command and using the provided Helm chart. There are alternative implementations. Actually, you can implement the Mercure protocol without a hub. If you are using Go or Node.js, you can handle the persistent connections directly by yourself if you want to. There are a Go and a Node.js libraries that are available if you want to write your own hubs. And there is a managed version with high availability support that is provided on the Mercure.works website. It's very fast. There are some benchmarks available. So the Mercure hub is free, easy to use, and easy to deploy. There are already support for the Mercure protocol in many tools. There are official supports for the built in the Symfony and API platform frameworks, and there are libraries for many programming languages. I just want to show you a last thing. It's how to use that using API platform and React. So API platform is a framework allowing to build REST API very easily. You just have to describe the structure of your REST API. Here, I create a PHP class describing a book. And I set a configuration option for the API platform framework called Mercure. Just with this single class, I get a fully featured API with support for JSON-LD, Hydra, GraphQL, OpenAPI, a lot of features, and built-in support for Mercure and async APIs. Not the specification yet, but async API. In API platform, there are also client tools that have native support for the Mercure protocol. So there are code generators you can use to generate from the API specification, client for React, React Native, Vue, Quasar, and a lot of things. With this single PHP class, I get something like that. Using the React application, I will change some data. A post request is sent to the server. The server detects that my entity has been modified and will broadcast the new version of the entity to all the currently connected devices using the Mercure protocol. As you can see, instantly, the mobile app that is connected to the same server is updated through the Mercure protocol. And it works the other way too. Mercure, since yesterday, is supported by the AsyncAPI specification. So you can document the messages that are sent through your Mercure API using AsyncAPI. And to do that, it's very, very easy. You just have to set in the AsyncAPI YAML file the URL of your Mercure hub, the protocol as Mercure, and describe using a JSON schema the content of your updates, of your messages, and that's all it works. I hope that you will try Mercure and that you find this talk interesting. Thank you very much.
Okay, hi again after live. So we just had a great presentation from Kévin, and Kévin is here with us live. So not much more from my side. Kévin, would you like to add something to your presentation?
Thank you for attending, and sorry for my terrible French accent. And just one more thing, we are working right now with some people, some contributors of the API platform project to add support for AsyncAPI itself in API platform. It means that in the next minor version, you will be able to use Mercure and get a documentation of the messages sent through Mercure in the AsyncAPI format.
That's the best message I've heard today so far. So thanks a lot. Very good information. Thanks a lot for joining and recording this talk for us and answering the questions. And I'll say, please stay with us. We'll have a short break now. Show some icons of the companies that sponsor the event. Thanks again.
For sure. Enjoy the conference.
We almost reached the half of the event, so welcome after the break. The next talk will be from Nauman Ali, and it's going to be about the increasing consistency and speed through the code generation. Remember, that's the last talk before longer break, so enjoy, have fun. Hear you in 15 minutes.
Hi, everybody. This is Nauman, all the way from Pakistan. I hope all of you are staying safe and staying indoors. So I've been in the API space for around 4 years now, primarily building API tooling, advocating about OpenAPI, building code generators. So a lot of experience around it, and I've really enjoyed working with the community because the API community is great. You all could agree on that. So today I'm going to be talking about AsyncAPI and how we can use and leverage AsyncAPI to build really consistent event-driven architectures. And it's been great to see the rising popularity of AsyncAPI itself, and how people are really coming around to it. And with this conference, I think we've really gotten to the next level. So starting off, I think we got to learn a lot from OpenAPI and how we've come along as a community there. So OpenAPI, starting off, we were having these competitions between Raml, Blueprint, OpenAPI, all of these different description formats, but finally and thankfully so, we came around to one. So I think one lesson certainly is to stick to one format, and with all the tooling that we have seen and the amazing things that people have done with OpenAPI, I think we can all agree that their descriptions themselves are amazing. We made a big mistake of not adopting it early enough. So we saw a lot of inconsistencies, a lot of tooling that wasn't really supporting the right versions. And yeah, now that we have come to this point, we're really designing those APIs first, getting feedback from them, and then really going on from there. So I think there's a lot to learn from OpenAPI itself. And considering AsyncAPI is a sister spec of it, we can really take those lessons and apply them there. And that's what I'm going to try to do today. So yeah, from the lesson learned there, we need to create async APIs for all of our APIs, like religiously. Because once you start implementing them and there are no API descriptions, there are so many discrepancies that start to appear, especially when your organization has more and more APIs coming along. So really, this is a no-brainer, create your async API descriptions. Then what we tend to see is, because a lot of the times there are versions that are just cropping up, there are breaking changes that are happening in APIs. We've all seen those with APIs that we have developed, especially when an organization becomes large enough, and then it frustrates us as developers as to what's happening, and even developers are consuming it. So the lesson for that is design first. Before getting into implementations of your APIs, if you actually design it first, what you can do is really get early feedback from your stakeholders, because honestly, changing code is painful. Going into a version, creating a new version of it, maintaining all those different versions isn't really pretty. So you'd rather change the design itself and get feedback on it and really decide on the contract before you move forward. This contract or this async API that you're creating would act as your single source of truth. This is where we'd be taking our lifecycle forward from. Having said that, we're all good with creating API descriptions yet. What happens is we see all these inconsistent interfaces. So some people are naming their parameters in Pascal case, some are naming them in Camel case. We're seeing documentation that's mostly incomplete, missing descriptions, missing example values, and it really doesn't make for a pretty experience. So you've got to follow a style guideline. Now, with a machine readable description on your hand, what becomes really nice is you can actually automate this process. And today I have news for you. So just over this weekend, people have guys at Stoplight have created a new version of Spectral. So this tool that we love to link our OpenAPI documents now has support for AsyncAPI. So you should really check out this new version that has come along. You can find the link right down there. So what you can do with Spectral is going forward from actually validating your documents, you can lint them and really lint them against a predefined rule set. So it's not just about validating the schema, it's about validating, are you following the right conventions? Are you not missing out on descriptions? And with this tool, what is amazing is you can create custom rules. So say in your organizations, you just want your names to be basket case. You can set that, create a custom rule set. You want to only use MQTT in your organization for one reason or the other, you can enforce that or even just like recommend that. So it's not a case of just going all the way or not. You can create different levels of warnings in your style guides, depending on where your API program is and how you want to take it forward. And just as you can see in the screenshot here, all you need to do is go into your CLI, lint this description, and you should see a list of things that you're doing wrong. Really, you can also do this in your Visual Studio Code. There's an extension for that, or you can make it part of your CI/CD using a GitHub action. But really, it's really powerful. So we've built a beautiful API description. It's consistent. All of the people are really following the conventions there are, but you still need to implement it. And if the implementation doesn't respect the contract that you made, there's really not much use of the contract there is. So again, with a machine readable description, you can generate code, both server side and client side from it. So it really ensures that your developers are focusing on what's important. So it's writing actual logic for your APIs and really building functionality, while all the redundant stuff is done by the generator. And on top of that, and very importantly, your APIs are built according to the contract that you decided on first. So this amazing tool that folks from AsyncAPI have created, this generator, allows you to generate code in Node.js and Java for now, but yeah, support it, add more templates, and I think this is really the way forward to go. Now, you've got a good implementation, you've got a good description, but developers who are actually consuming this API, your implementation, are still struggling. Why does that happen? It's bad documentation or incomplete documentation. With an AsyncAPI and a good contract that is up to date, you can actually generate documentation too. So you can either generate it in Markdown or HTML. Don't miss out on descriptions and examples in the AsyncAPI, because that is what really makes for good documentation. You can actually add these as rules in your Spectral pipeline and set descriptions or examples are necessary. Maybe even multiple examples are necessary. That depends on how you want to go about it. But really generate this documentation from it. If you want to put it somewhere into your own documentation, you can generate a Markdown version or take an HTML version and publish it to GitHub pages. It's really going to make your life easier. With your documentation ready, I think a big part that we miss out on, especially in organizations, is you need to put this documentation for developers to discover. So create a central hub where all your documentation generated from your API, AsyncAPI, is hosted. So a central hub where people can find, search, and really consume your APIs. And so you don't end up, your developers don't end up really creating duplicate APIs or doing the same thing. Now, a description and all the things that you can do with it, don't really leave these steps as manual, because you can't really trust humans. They do end up making mistakes. I think the picture says a lot, but automate this process, make it part of your CI/CD pipeline. So from your contract being written to your code being generated, your documentation being generated, and then being landed, all of this should be an automated process. And always keep the design first step first. So you're going to design it first and then really take it from there. So yeah, design, the lint, mocking we're missing out on. We'll talk about it a little too. But generate your docs in code, you implement it, you publish it, and really automate this whole process so that you can go back and forth on this without losing the consistency that we so badly need and are targeting. Now, I think AsyncAPI and the tooling has really come a long way, but there are missing tooling, and considering we're doing all of this open source mostly, you should really come in and contribute where you think you can add value, or something that you build for your organization, you can contribute back. But we having a mocking server or a mocking tool for AsyncAPI would really make parallel development easier. So you'd really go much faster than we can right now. And we can even have contract testing. The code generator itself that we talked about before has templates that are still missing. So you can obviously contribute to that. And even though writing descriptions in a text way is okay, but it's not really pretty. So UI editor would really be nice. Hopefully build all this open source. So yeah, thank you so much. I hope you can take some ideas out of this and really get your pipeline sorted and make consistent APIs. So there are some links here to Spectral, to the AsyncAPI generator, and then there's a demo for what I was talking about on my GitHub, so you can find it here. And yes, I'm open to any questions or conversations after this. Thank you so much, and great work, Fran and team, for the conference that you have brought along. Thank you.
That was our last talk. Hey again, live. Thanks a lot for this presentation, Nauman, and thanks a lot for joining us live here. So yeah, the stage is yours. Would you like to add something?
Yeah, I just wanted to thank you, and great work, all of you guys. It's an amazing conference. It's pretty well organized, and yeah, thank you so much for having me. If anybody wants to ask me anything, please connect with me on LinkedIn or leave a message in the chat, and I'll get back to you.
Yeah, so we actually, I think, I mean, thanks, of course, but we actually have some questions in the chat, and I think we have time to read them, right? We have a question from Gerald Leffler. I hope I'm saying it correctly. He says, what type of repo do you recommend for the central repo for API specs?
Okay, so it's a central repo is, so what you can go for is either a multi-repo or a mono-repo approach, but keep your specifications inside the project itself, and just create a CSED on top of it so that you can create a central view of it. But having your specifications at multiple places can cause inconsistency. So keep them with your project itself, and I think that would be the right way to do it.
Awesome, makes sense. So yeah, I mean, I think we still have time. Sometime. Well, actually, right now we're going to the break, right? So yeah, so far I think I'm enjoying this conference a lot. We're all learning here. You might see what's happening behind the scenes here. It's crazy. It's like we're all like now, yes, not now, not yet. Fuck. It's amazing. I love it. I'm loving it. It's like you don't know how to do it. It's the first time we do this, and we don't really know how to do it live. So I hope that the result is at least decent, if not good, right? And yeah, but enjoying it so far. Thanks, Nauman, for joining us as well. And yeah, if you want to say some words, stage is yours.
Just that. Thank you so much, and it's going pretty well up till now. So good work with that.
Yeah. Thank you. Thank you, man. Cool, folks. So I think it's time for a longer break, right? We'll be, I think we're coming back at 3:30 more or less, 3:34. It's a 30 minutes break, more or less, for us in the European, more or less European time zone. I think it's time for late lunch. Or a beer, who knows? And for those in Australia, like Paul, I'm not sure if Paul's still awake or he's already sleeping. But if you're awake, mate, just have a beer for us. And for those waking up early on the US, take your time to have a breakfast. And we're coming back in about 30 minutes. Thanks. Hello again, folks. We wanted to join together again, the three of us, to give the good morning to the Americas. So most of the Americas are just waking up now, or recently. So yeah, just a quick thing that I would like to mention before we welcome Norberto, our next speaker, is that yeah, so we'd like to be thankful for all the work that that Lucas, present here, and Eva are doing into the making this whole event possible. So as you may know them already, but Lucas has been taking care of the community for some months already, and so he's probably the guy you should reach out to on Slack if you have questions, and also if you have some criticisms against AsyncAPI, just go directly to him. Don't bother me. So yeah, I'm kidding. And yeah, and Eva is actually the person making the magic happen behind the scenes. So all of this is actually possible because of her knowledge on video editing, video live streaming, and all the stuff. So yeah, thanks for that. And also would like to thank our super nice community, right? So we have a vibrant community that's growing a lot, and we're super thankful for that. And I hope we're giving back all as much as we can, right? I hope that this serves the we're doing it right. So yeah, next talk is Norberto Herz. He's from Argentina, and he's going to be presenting Jukeberry. It's a don't know if call it experiment, an IoT experiment, or I'm not sure if it's still experiment or not. But it's pretty cool. Go to the YouTube chat and follow the instructions there to install the client, because he's going to be doing a live demo after his talk. That for those who don't know yet, the talks are being pre-recorded, so they have been pre-recorded. So now what you're going to see is a recording. So so Norberto is going to be there to answer your questions. So feel free to ask questions anytime. And yeah, so he'll join live with us after his talk to do the live demo. I'm looking forward with that for that, because it's pretty cool. Anything else you want to mention, Lucas? Maybe, I don't know.
Yeah, just add that we have some vouchers for our swag store for participants. So we want to somehow give back to the community. So we're gonna give away 12 swag packs to 12 the most active people in the chat, asking questions and getting answers. We're gonna do the drawing next week, and all the details will be in the chat. So just watch the chat as well during the presentation.
That's true. Cool. So no more chatting here. Let's introduce Norberto, and thanks for your talk, man. Video in.
Hi, my name is Norberto, and I am a software builder. That's what I do, and I have been doing that in different roles for almost 20 years. I am currently working as CTO for a startup fintech. I spend my free time with my wife and 2 little kids, and when I am not with them, I play guitar, piano, and other few things. I also like to work on domestic Internet of Things projects with an Arduino and a Raspberry Pi. I'm here today to tell you about Jukeberry, show a little recorded demo, and maybe do a live one with all of you at the end if everything goes well. So before moving forward, if you want to participate on that demo, please do. I want to encourage you to do that. And you have a node environment on your machine, please follow the instructions at the link at the bottom left to install the Jukeberry client on your computer. I really promise it won't delete your SDD. You can even check the code since everything is published on GitHub. Stay tuned to the comments on the YouTube channel for following up the demo at the end of the presentation. Jukeberry is a Jackbox. You know, those machines that used to play music in bars around the decade of 50s and 60s. In this little remake, the way of choosing a song is by holding an RFID card near to an RFID reader. Each card has an associated song. For example, in this case, I have these ones. Oh, some Radiohead songs. That is a band that I love. So it's a nice gadget. It's relatively simple to develop. And if you are able to build some nice case, maybe one built in wood, it may look good in your living room during a social meeting. Of course, once COVID is over. Meanwhile, please stay at home. Well, what usually happens to me is that once one project is running, I start thinking of more features. Okay, and in this case, the features simply appear in my mind. I took a notebook and wrote this down, and later on, I pushed those to a GitHub repository so I don't forget it. You can check those draft ideas on the link at the bottom left of the slide. But anyway, I will tell you about some examples of those other ideas. The basic one is playing songs, of course, but a more evolved one would be playing songs on multiple devices. Let's say you have a Chromecast, an Apple TV, a computer, a cell phone, whatever. For doing that, I need to build a network of connected devices that are invoked or notified when a user holds a card near the reader. Okay. Now, if I can have network of devices, that one needs to be differentiated from the network connected to a different Jukeberry, because of course I can build more than one Jukeberry. So I need a way to register a Jukeberry or the network directly and the devices on each particular network. So suddenly I need some kind of device manager. I also need a way to manage songs. Let's say upload the song until it's integrated with Spotify. And I also want to have guests using their own cards or NFC compatible cell phones to play a song when they come home. So it seems like the manager should live on the cloud. But at the same time, I want the Jukeberry to be able to work even without an internet connection, at least for the most basic feature that would be just playing a song. As you can tell, the scenario became more complex and more fun. And now the project is heavily relying on using APIs to connect all these components. So what's about REST? Well, as I said, I live with 2 little kids. So getting REST is a bit difficult during the quarantine, believe me. But seriously speaking, what about going through REST APIs? Well, it actually could work. It is as simple as getting the Raspberry, calling an API on the device that will play the song. But what happens if I have several possible devices? Which one should I call? It seems like there should be some kind of logic at the Raspberry to route to the proper device, to the connected device. And if I want to do so, those devices should be registered within the Raspberry. What if the Raspberry is not available when one of those devices are going to register? If we think about it, we can solve that by deploying a separate component that manages that logic and routes the API to call to the corresponding device. The component must be developed, maintained, and more important, be available every time I want to play a song. Furthermore, we cannot expect the Raspberry or our Jukeberry to be a highly available component. I might have only one of those connected through my domestic ISP using a simple power supply. So registering a new device, managing songs, users, or any information that should be known by the Jukeberry are features that must be available regardless the Jukeberry. Lately, Jukeberry should be able to catch up when it comes available, asynchronously. It sounds like REST APIs are not suitable for doing that, or well, actually, it's not an issue with REST itself, but with the concept of building synchronous transactional services. You know, I call the API, I went until I get an answer, and either it's an okay or an error. If it's an error, I could retry until I succeed, and maybe that never happened. So it seems one of those situations where we could benefit from an event-driven architecture. Just in case it's the first talk you're listening today and you're not familiar with the concept, in an event-driven architecture, components are producing and or consuming events. These events inform something that happened instead of commanding something to happen, like a typical request. So a producer won't wait for any kind of response from any of the consumers. Furthermore, it may even not be a consumer for a particular event at a particular moment. Consumers observe events typically by subscribing to a channel and react upon this at their earliest convenience. Related to the checkbox, for instance, the Raspberry could produce an event describing that a card was read and publish it into a channel. That event might include information regarding the card, the Raspberry, the context, for example, at what time did the event happen. A set of devices might be subscribed to that channel and react to that event by, I don't know, in this case, playing a song associated to the card. If a particular device is not available at a specific time, it will simply miss that event. It makes no sense to start playing the missed songs when it becomes available. In that sense, it's a bit like the UDP protocol, in which if a datagram is lost or delayed, you're not going to wait for that, since it won't make sense to use it when it reaches the destination. A different scenario is when a song is uploaded or registered. Since I want to manage that from different places and make it available for different users, I decided to place some service on the cloud. Every time a user registers a new song, the service produces and emits an event. The Raspberry subscribes to the corresponding channel to get a notification and store the song information internally, so it becomes available when the Jukeberry is offline. But the Raspberry may be offline when the song is registered. In that case, the event can be stored for different consumers to catch up later. And this concept is the cornerstone for another great idea, which is named event streaming. Event streaming states that you have a stream or flow of events that is capable of representing the state of a system at any time. You just need to read all the events until a particular time to replicate it. Tools such as Apache Kafka makes it possible to consume those events in an efficient way. And for sure, this scenario is more like TCP works. Packages can be delayed or arrive in a different order from the one that were generated, and the system must ensure this will reach the destination and that the message can be reassembled in the proper order. So going back to business, both scenarios are part of event-driven architectures and can benefit from asynchronous communication. And that's how this project meets the AsyncAPI initiative. So I started by writing a very simple AsyncAPI definition. First, I wrote the header, which includes some information about the project and the definition itself, such as the AsyncAPI version. I also specified the servers. This API is just for the media player part, which uses an MQTT broker. In this case, I am using an Eclipse Mosquito in the cloud, for which I want to thank to Solus that provided it. I also defined two channels. The first one is the corresponding to the event when a card is presented. The clients can expect a message to be published here when the user holds a card near to the reader. The message format is also defined on this section. The second channel is the stop push one. Clients can expect a message here when the user pushes the stop button. And there is a security scheme under the component sections. Components objects represent reusable objects, meaning that I can simply refer to this in other parts of the definition. Then I use an existing code generator for creating human-readable documentation. I did it manually by running the command at the right button, but you can easily integrate that command to your continuous integration pipeline, so you have the documentation up to date with every API change. I used the same generator for creating the node client, which automatically solves the routing logic and leaves a clear handler where to implement the business logic. I had this client up and running in less than 10 minutes. Also, I was able to learn by reading the generated code. And yes, if you're about to cry, it's a proof of concept. It is okay to hard code some stuff when playing with technology, right? Finally, for the Raspberry code, I didn't use any generator. I think I will write the Python template for the code generator once I have some time. As you can see, the code for connecting and sending a message is pretty simple. And now it's time for the demo. I am going to record it right now and show it. And well, I don't know, let's play some music. So for the demo, I have a different setup here on my desk. The reason is that I need to record different components. I have this support for the camera. It's really domestic. First of all, I am going to present the 3 cards that I have prepared with different songs, all from Radiohead, which is the band that I love. Okay, what I'm going to do is to move this close to the reader and start playing. For that, I am also going to switch to a different camera. Well, we are also using a different microphone so you can catch the noise from the environment, which is the one that is more proper to listen to the sounds. The reason why I have a camera pointing to the screen instead of doing a screen share is that I want to simply start the node player, but after that I want to be able to show the device. Yes, this is the Jukeberry up and running. It's a Raspberry Pi 3 connected to well, different stuff. One of these is an RFID reader, as I said before. And what you have here is a button that I am going to push when I want to stop the music. So let's start by using one card, that is the crypt card. Let's see what happens if I move it close to the reader. Okay, so enjoy the silence or the music. I am now going to try with a different card. Let's try to play high and dry. Okay, and let's move to the last card, it's for the snatcher, another thumb. Okay, so I think it's enough demo for now. I'm going to push the stop button right now, and it's going to stop music. Yes. Okay, that's all for the demo. Maybe we can try right now to do some online one if you have already installed the client.
Okay, folks. So great presentation, Norberto. I think you want to do a live demo, right? Right now.
If it's possible, it's an experiment.
So let's do some quick things here. I think you all are seeing my terminal, right? I'm gonna run. I was already running previously the code that we shared on the YouTube chat to configure Norberto's Jukeberry client, and so I'm gonna just run npm start to run it. Okay, so yes, you all can see it. Perfect. So this is the MQTT client listening. You can probably already use it or do the demo, Norberto, or explain what's happening here. But let me just do something. Since I'm using my my earphones, you will not listen the music, right? So I'm gonna disconnect this.
That's clever, and I am going to do some signs with my hands so you can understand what I am speaking right now. So we now, okay, just okay. So we have 16 connections. It means that 16 people should be able to listen to the music once we start playing with this. So once again, I have the cards here. It's really homemade, so nothing very fancy. What I'm going to do now is to switch the camera so you see the Raspberry. This is it, okay, in the flesh. And I'm going to start the program here on the Raspberry Pi right now. So everything should be working. I'm going to start with this random card, and you will let me know if it's working. Okay, also with the comments in the YouTube channels. I hope it does. It's an experiment, once again. Yeah. I hear it from here. Yeah, people are hearing as well. So let me switch to another song just very quickly. As you can see, I really love Radiohead. So I'm going to do all the demo with this. And I am going to end with this one. So turn the volume up as much as possible at home. So I will set some endorphins on your torrent, okay? I hope everyone are dancing there at home, okay? So the last thing that I have is here, my stop button that I push so you can hear me again. Yes, okay, so it seems it's working. I'm really happy of having that working. I'm going to switch the camera again, but I think this is it. What do you think?
That's really amazing. Man, I loved it. I really wanted to share this with the people. Like I was telling Norberto the other day, like we have to do this live. We can pre-record a demo, that's fine, but it will be cool for people to see it live, so we can share the code and they can experience themselves on their machines, right? So this is amazing, man. I mean, congrats for doing this, and I'm so happy that you did it with the AsyncAPI generator. I mean, it's like
yeah, and I will contribute to the Python as well. When I started with this project, I didn't write Python code at all, and now I can contribute to the generator as well. I think it's a great initiative, and I love being involved somehow with some open source projects, something that I really missed.
Yeah, no, that's for sure. In that sense, I think I need to mention the great work the Solaz folks are doing on the code generators on Java and the Python now. So Michael, not Mike. So Michael is working on the Python generator, and I think you should probably coordinate there. Even not just you, but the whole community. If you're interested in a Python generator, I strongly suggest that you all coordinate the efforts there, because it will be really cool. By the way, I mean Michael Davis. Okay, so I said Michael, but I didn't say who, which Michael, right? I was meaning. So yeah, he's doing a great job, and yeah, so my round of applause for the Solaz folks here, doing a lot of great contributions. Let me just check the chat, because we have time. We have lots of time for questions. So yeah, and is there anything that you want to ask? We have lots of time for questions in this talk, so feel free to jump in and chat, and I'll be happy to read your questions aloud here on the live stream. Yeah, so well, I think yeah, that's a good question. So so Mobile Jones is asking where to find the Python generator. It's not yet done. It's actually something that we're now starting to work on. Let me just share this with you folks, because I think I already created a repo for Michael Davis some time ago, and maybe we can share that. And yeah, let me find it. So this is, if I'm not mistaken, this is Bajo something, maybe. Python PAHO. So we're gonna be creating an AsyncAPI code generator for Python using the PAHO the PAHO framework. Oh, look, so so Lucas has been faster than I. Perfect. So so yeah, and if you have a look, so Tamimi has a question for you. Curious to know, have you considered using other messaging protocols apart from MQTT?
Well, actually, yes and no, because for this I wanted to go with MQTT since it's very prepared for Internet of Things projects. So it was kind of the obvious decision to make. For sure, before that, I was considering doing all this stuff by using RESTful APIs, so just HTTP, but it didn't seem proper because of the reasons that I mentioned during the presentation, the synchronous and transactional part that I didn't want to. But the funny thing is that for being able to sync, as I said, all those other services that should be available on the cloud, while the Raspberry could and probably will be offline, I will be using Apache Kafka connections so I can start doing event streaming. In part because it's useful, and in part because I want simply to play with the technology once again. So that would be the short answer.
Awesome, man. I think it's this experiment that you created reflects very well the usefulness of the MQTT protocol first, and it's very easy for people to understand that the value behind it, right? And that you don't have to jump into a big IoT project to see the value here. So that's something really cool. And also,
maybe just a clarification is that I am using it for something that is really simple, and maybe I am going to generate a couple of events per minute. Okay, the MQTT protocol is thought, designed, and prepared for supporting millions and millions of transactions on short periods of times, because the magic with Internet of Things is that we are going to be putting sensors in all the world that are going to continuously be sensing information and sending it. So let's suppose that I want to change the volume of the songs on your computers by using a resistor here. I should be sending that in a continuous way, so it probably would be much more events per second. And even though that's going to be something very simple for MQTT, we are talking of servers that will be supporting high volumes of information that will be collected from devices, and after that processed by big data infrastructure and all the technology that will make possible big things to happen. Maybe it's super relevant for this context of the COVID-19, where we could design some diagnosis mechanisms that actually triggers alarms or start measuring what's going on with population on different areas, so we can understand and follow the virus through different places. And I think that MQTT will be a main player for that.
That's so true, man. We have a curious thing happening on the chat, which I like it a lot. The things about being live, right? So David Viesak is asking us if you could play the music again. People will not hear it on my computer anymore, but he even suggests if you can be playing this during the whole conference from time to time.
I can do it. I think I am going to bother people, but it's always your choice to simply exit the client. Let me do it. I am going to do it. I am not going to switch the camera again. If you have 3 songs for choosing, if you want to leave a comment there and let me know which one you want to be hearing. So I am playing right now Body Snatchers.
Oh, I'm gonna turn off my client when this is killing my ears.
Oh, so it is on.
That's amazing. That's super cool. And also Michael Davies is asking, like, how about we make a generator for MQTT on Arduino? I think that would be like super,
Let me work on it in a couple of days. Well, let me a short anecdote here. Couple of days before the presentation, while I was working on it, my RFID reader just broke. I couldn't make it work anymore. And on the context of the COVID, it was very hard to find a new one until here the regulations start being more flexible. So I got a couple, one day before recording the presentation, I had to prepare it and make it work again. But in the middle, the solution was going to be to say, okay, let's see if it's working on the Arduino. So I will make the client to connect, actually the server to connect directly from the Arduino to the server, and the Jukeberry will work on that. And it won't be called Jukeberry anymore because it's Arduino. The thing is that I started with the Raspberry Pi because it already has Wi-Fi, and it already has a sound card. So before doing all that stuff with the MQTT, it was going to play locally, and that's the reason why I chose this.
Amazing. So thanks, Norberto, for joining us today. It's been I think it's been an amazing talk, man. It's again, thanks a lot. I really appreciate that you took also the risk, let's say, of joining live and doing this demo, this live demo. Thanks again. So
it was fun for me. Thank you.
Thank you. So yes, we're gonna do a short break to thank our sponsors, and we'll go next with Doug Davis from IBM and CloudEvents. Thanks. Okay, folks. so we are back from this little break. I think so far I haven't took the opportunity to thank our sponsors properly. So I would like to thank Abel. I would like to thank MuleSoft, OpenAPI, Red Hat, SmartBear, Solaz, Slack. We're super happy that you're all supporting us and the community. So big shout out for them. Next up is Doug Davies. He's a PM on IBM. He's a PM of Knative on IBM. Sorry, and he's also part of the CloudEvents project, which I'm super happy that he applied to speak at the conference, because we wanted to have also this vision, or give this vision to people, that it's not AsyncAPI versus CloudEvents, right? Like I've been asked it many times, like, should I use one or the other? Which one is better? And it's like none of them, or both of them, depends on your use case, right? And these are two different things, and I would like people to understand, and from them, from the CloudEvents people, how to use CloudEvents and when to use CloudEvents. And yeah, so not entertaining you more here, and I hope you enjoyed the talk from Doug. Thanks.
All right. Welcome, everybody. My name is Doug Davis from IBM. I'm one of the co-chairs of the CloudEvents project, which is a CNCF project. And basically, CloudEvents is a project that was designed to help people manage events, basically around delivering events from one spot to another. But before we actually start talking too much about the spec itself, let's talk a little bit about the history in terms of why CloudEvents was even created and what led us to even think about creating or working on it. So back in the middle of 2017, the CNCF Technical Oversight Committee wanted us to take a look at serverless technology. It was a relatively new technology at that point, and they were really just trying to figure out what, if anything, should the CNCF do about serverless. And so what they did is they started up a serverless working group whose main purpose in life was to do just that, produce a white paper that sort of explained what is serverless, how does it relate to other technologies like functions as a service, platform as a service, or containers as a service, the other as a service offerings out there. State of the ecosystem, what's out there today from a proprietary perspective as well as open source perspective. Basically just trying to help you understand what is this space actually all about. And then finally a set of recommendations, if any, for what should the CNCF actually do about serverless, right? Should they ignore it? Should they get more involved, try to promote projects around it? And so that's basically what the serverless working group first did, is just sort of lay the groundwork for what's out there today. Well, one of the recommendations that they came back with, or we came back with, was that we were thinking about, is there a way that we can actually help the end users out in this community? Because there was a lot of really great, unique serverless solutions out there, but there really wasn't much in the way of interoperability to make life easier for people. So for example, one of the things a lot of people focus on around interoperability is, well, can I move my function or my serverless function from one platform to another easily? Well, not really, right? Unless they happen to share the same code base because it's open source. More often than not, they're kind of proprietary APIs around, say, the function signatures and stuff like that. And so there were things like that we sort of identified, but we realized some of those things that would really, really be great to do would also be really, really hard to do because they're going to be political and controversial. And we're not quite sure whether the industry overall was really ready to tackle that space. So we looked around and said, are there some what we call low-hanging fruit that we can actually tackle in the meantime, sort of building up to that? Get the community and the people producing products in the space comfortable with the idea of interoperability to help out the users. And we realized a lot of serverless is about event-driven workloads. So we thought, well, is there something in the eventing space that we can help people here or help out people with? And we talked about, the delivering of events from one spot to another, and in particular to your function, is something they all kind of do. And there may be some help we can attack, or something a problem space we can attack there and help people out, okay? So let's talk about what is actually the pain that we sort of identified, right? So if you look at this picture here, what you see on the left-hand side is you got a whole bunch of these devices or event producers producing events. And eventually you want that event to go all the way to the right-hand side, right? To a data lake or to a function or something. But in the process of getting there, it can pass through many different componentry or middleware, and it may actually be transported over many different protocols, right? And the problem that we have here is while this kind of works today, the real pain is at every single one of these little blue boxes, it has to understand what the event is that's coming into the system, at least enough to know how to route it appropriately, right? And how to get that metadata out of the event to know, for example, well, is it supposed to go over this NATS, Kafka, or MQ thing to the event stream broker, or is it supposed to go down to that pub sub queue at the bottom, right? Those kind of decisions in terms of routing and stuff like that need to be made by middleware. But in order to make those decisions, they now have to understand the message itself. Now, they don't necessarily have to completely understand all the business logic of what's in there, but they have to at least understand the syntax of the message coming across, so they know which bits of data they're interested in and where it is in those messages to be able to extract it to make those kind of decisions, right? And that's not easy, right? Because you got lots of different producers producing lots of different events in lots of different formats, and there's no commonality for the most part between them, right? It's a free-for-all. And so that means every one of these blue boxes potentially has to continually update the sort of its understanding of all the various messages that come into those systems. And then what if those syntaxes change over time, right? You got version 1, version 2, version 3 of these events coming through. All these blue boxes have to understand that. That's a lot of work and a lot of maintenance. Obviously, you can do it today, but that's a pretty big pain point for people, right? And so this is really the type of problem that we were trying to address, is how to help the event from point A, meaning the event producer, to point B, which is your function eventually, but help out that middleware to get it there, okay? So in 2017, at the end of 2017, CloudEvents was born. And as I said, it's an offshoot of the serverless working group. And basically the goal here is to try to define common metadata for these events and where they appear in messages. Now, keep in mind, this is not yet another common event format that tries to force everybody into a single standard for what your event looks like. That's been done many times before with not a whole lot of success. And so we decided to take a different approach. We said, if you look at all the messages that are flowing around today, most of them actually have a lot of common data to them. So for example, a lot of them have some sort of type field that says, you know, is this a create versus a delete type of message, right? They have a unique identifier, so you can do dedupe type stuff. They have information about where it came from, right? Source and subject, right? What produced the event and what is the event about, right? So for example, if it's a GitHub bucket, the subject may be the GitHub repo, right? Yeah. Then we have the time, right? When was this event actually created? Right? So you have all this common metadata that most events typically have already. So with that, so we took a step back and said, well, what if we take this common metadata that most events have and at least give them a well-defined name and a well-defined location in the message itself, so that the middleware doesn't have to guess or understand all of the messages that are coming through, rather they just have to know where to look for this particular metadata. And that's basically all the spec is, right? Common metadata, common location, and that's it. And it's not even all metadata. It's just enough metadata to help the routing get of your event from point A to point B, and that's it, okay? It's actually a really, really simple spec with very simple goals. It is not trying to change the entire world. It's just trying to reduce this one little pain point. So I like to tell people, this is not a sexy spec, but people are finding it incredibly useful. So it's one of those specs where I'm hoping it sort of weaves its way into people's a middleware, and it just sort of does its job. But it's not designed to be very flashy or make a lot of noise. It's just there to help people out. Okay. Now, I talked about how this metadata should appear in a common location, in different formats, and that's all true. But there's actually two different ways that it can appear in messages. The first is called binary, and that's actually my preferred way, because binary says you already have an event going from point A to point B. You already have an event format. You already have the structure of the message. You already know how it appears, say in HTTP or whatever transport you're using. All CloudEvents is going to do in that point is add extra metadata to your existing message, leveraging the existing extensions of that protocol. So let's take HTTP as an example. In that particular case, for a binary format for CloudEvent, all that really means is adding a couple of HTTP headers to the message. That means a couple of interesting things. One is you don't have to crack open the HTTP BY to look at the message. as a router anyway. And you as a middleware know exactly where to look for the message. And third, it doesn't have to be break existing implementations, meaning a receiver that knows how to receive that message but knows nothing about cloud events will still work, because these attributes that appear as HTTP headers won't affect your message. You know, HTTP allows you to have extra headers in there that the receiver can just ignore, and that's what it'll do in this case as well if it doesn't understand cloud events. But over time, if that piece of middleware does, you know, grow up and understand cloud events, now it can start leveraging those things and can stop having to understand what's in the body at that point in time. It can start using just the cloud events headers to do its routing. Okay. Now, the second format is called structured. This one says, you know, if you don't have an existing event that's flowing around and you want some guidance to help you out there, fine, we'll help you out there. We'll actually give you a JSON format that you can use for your cloud event structure, or for your event structure if you really wanted to. And that's an option. And I'll show a little bit more about that on the next slide. But you have these two options for you. And as I said, my preferred approach is the binary one, because that basically means that existing message flows do not break at all. And they can still be used with your existing infrastructure without any changes at all until they want to actually support cloud events. So let's take another look at what this means through an example. So let's say you have a event being shown, or event flowing as shown on the left-hand side here, right? Very simple little HTTP message, nothing too exciting. But notice what happens now. Let's add a couple of cloud event headers to it, just 4 little headers. First one tells us the spec version. So this is the cloud event specification version that we adhere to, 1.0. It's the only version we have out there. CE type, so this is the cloud event type. This basically allows the receiver to look at this one field and say, okay, it's a new event from bigco.com. Now, obviously the phrase new event is a very, could be a very popular phrase. So you may want to classify it based on, where it's coming from. And this allows you to say, it's not just any new event, it's Bigco's new event, right? So you give a little bit of scoping there, right? But typically, but you can obviously put whatever you want in there. It's completely up to you. It's just a string. Obviously, the more specific you get, the less chance of you having conflicts with other people. And the more specific you can be also allows for finer grained routing if you really wanted to. Okay, source, obviously this tells you where the event came from. So in this particular case, you could say that the bigco.com's repo component is the one that actually produced this event itself. And then we just have some unique identifier, as I said, mainly just so the receiver can do deduping and know if it's seen this event before. Very simple stuff. So again, nothing about this message has really changed in terms of a receiver that knows nothing about cloud events. But if you understand cloud events, now you can do routing based upon these 4 little headers, and that's it. Okay, that's the binary format. So let's take a look at the structured format. Now, the structured format, if you look at it, it actually has basically the exact same data. The only difference here is we define what goes inside the HTTP body, because in this particular case, the person who's using this said, I don't have a format that I'm already adhering to, so give me one that I can do. And just because they don't want to define one themselves, we said, okay, here's what it looks like in JSON. If for some reason you don't have your own format, or you don't want to pass these cloud event metadata as HTTP headers, because there are some people who don't want to process headers. They actually want it on the body, and that way we could take the entire payload and pass it on to the next component in one large chunk of JSON. And so we provide that as well. But if you look at it, it's basically the exact same data. The only change here is we define a data content type. So you can say what is the format of the data itself, which maps to the content type header from HTTP. And then the actual body of the message that would have appeared at HTTP body appears nested one level down under a data property. But you can see it's basically the exact same thing, right? So pick your poison, whichever one suits your use case. We got you covered basically. And you can tell the difference between the two, because if you look at HTTP content type header, on the binary, it's still the original application JSON. On the right-hand side for structured, it's application cloud events JSON. So that's how a receiver can know which format he has. And we do, I believe we actually require both to be supported by implementers. That way you can actually, as a sender, send whichever one you want, okay? And that's basically it in a nutshell. It's not that hard, not that complicated, but it addresses that pain point of allowing routing to get the job done without having to understand the business logic of the event, or have to understand all the different flavors and syntaxes of the events coming in. Now, so who's actually using this? Well, for those of you who know about Knative, which is an open source functions as service offering, Knative actually took this to heart. And what they basically did is they made their eventing model under the covers completely leverage cloud events. Now, the eventing part of Knative basically is there to help people with the delivery events into their Knative environment, meaning where their function is hosted or their service is hosted. And what that basically means is they take the event as it comes into the system and normalize it into a cloud event. And at that point, everything that goes between the various componentry inside of the eventing infrastructure of Knative is passed around as an HTTP message wrappered as a cloud event. So as you look at those various components, if they need to do some special logic like routing and stuff, they know it's a cloud event and they can just use those headers, right? So you get that commonality. So let's look at that with a more concrete example. So you have an event producer who's setting an event into your cloud native environment. In the most simple case, what's going to happen is it's going to get received by some component called an adapter. And his purpose in life is really just, as I said, to take the event, convert it to a cloud event, and then send it on to the next component. In the most simple case, the next component is going to be your service itself. Nothing too exciting. And at that point, technically, cloud events may not provide a whole lot of value, at least from a middleware perspective. The service can still use it, right? The service will know it's a cloud event. It can use those headers if for some reason it needs to in its message processing. But from a middleware perspective, we don't have a whole lot of middleware, so there's not a whole lot of not a whole lot of benefit. That's fine. But what if you added something into the picture, like a broker, right? So let's say the broker is going to be doing fan out, right? So the event comes into the broker, and maybe there are a whole bunch of different services that are subscribed, meaning they define these triggers. And so you're going to get this fan out of the event to multiple people. Well, in this particular case, triggers can have filters. And in cloud events, in Knative, you can actually specify those filters basically by doing string matching on the cloud event attributes, right? So at this particular point, the broker does not need to know anything about the type of event coming in. It doesn't need to know whether it's coming from some, high-end enterprise system or GitHub versus GitLab or any other event producer out there. All the broker needs to know is, I'm getting a cloud event and I can do this filtering because the filtering is processing over the cloud event metadata, okay? And based upon whether it's true or false, it will then get passed on to the appropriate service. When the service is done, it can send back the reply to the broker, and then the broker can pass it on to the next component, again, as another cloud event. One of the other interesting componentry within cloud, inside Knative are things called parallels, and it's a different type of fan-out mechanism. Okay, in this particular case, an event comes into the parallel, and you can have a whole bunch of different conditions. And if any of those conditions are true, it's passed on to the appropriate sync. So it's a slightly different type of brokering type system or fan-out type system, but it's a very similar concept in the sense that as the events come through these things, they do filtering based upon the cloud event metadata. Okay, so again, this is, in my opinion, sort of the classic example of what cloud events was actually designed for, exactly this type of middleware processing. Okay. And so finally, just to wrap it up for the cloud event, from the Knative perspective, you can then mix and match these components to basically get an entire eventing workflow completely outside of your service. And it's all based on cloud events. So your event can actually go through this entire workflow thing, eventually reach your service, and you've done either filtering or whatever kind of workflow logic you want to have done on these events without ever having to really understand the business logic itself, unless you really wanted to, right? Which most cases, middleware, you don't. You just want to get it from point A to point B, and that's where the cloud event metadata helps you, okay? So let's talk about the core specification. As I said, it's really just about the metadata. So let's look at what that metadata actually is. I already talked about some of these. So you have the type, is it a create versus delete type of action, and who's create versus delete, right? So you get a little bit of a scoping around that action itself. The cloud event spec version is another attribute. Source and subject, combine those two to find where the event came from. In other words, who sent it, who's the event producer. And the subject is more about what the event is related to, right? So for example, in an object store, the subject might be the entity added to a bucket, right? So that's why you can do a little filtering to know, well, I only want to get events from one particular GitHub repo as an example, right? You might look at the subject for that type of filtering, okay? Unique ID, or I talked about that. Time, that one's easy. Or talked a little bit about data content type, right? That's the case where it's a structured type of thing, or a structured type of a cloud event. We had that field in there. And then we also have schema, right? A lot of people want to understand, based upon the schema of the event itself, meaning the schema of the business logic, do different processing, right? Is it version 1 or version 2 of this type of event? Send it to different processors. We allow for that to be in there. Now, it's important to understand that while we define all these things, only 4 of them are actually required, and those are the underlined ones, okay? And that's why I only showed you 4 in the previous example. The other ones are optional. They can appear there, but in order for the minimum to be a cloud event, you only need those 4. And the reason we kept it nice and small is because the other ones aren't necessarily part of every single event, but we also want to keep it really, really simple. Now, at the same time, you as an event producer or consumer, if you understand who your event producer is, you guys can extend this if you really wanted to. You can define extensions that can appear as other cloud event type attributes, and they have to appear basically in the exact same location, meaning in the HTTP case, in the binary format, as HTTP headers, prefixed with CE dash. That way people know exactly what CE headers or cloud event headers are in there, or metadata is in there, without having to necessarily understand everything in advance. Okay, and they could take the extensions, put them into a separate bucket, and that processor that understands extensions can go looking for them over there if they really wanted to. Okay, so that's the core specification. So other documentation that we have, obviously, as I talked about before, events could actually flow over many different protocols. So we support the 5 protocols you see on the screen here, HTTP, MQTT, AMQP, Kafka, and NATS. And basically, for I think almost all of these, we pretty much show you where the events are supposed to appear. The metadata is supposed to appear in binary format. In most cases, it's either in the extension attributes or headers type stuff, or how a message appears in the structured format, right? And what special rules might have to be there in terms of data types and stuff like that. As I said, I think all these support both binary and structured. I think only one of them, I think it might be NATS, only supports the structured mode. I'm not 100% sure, but most of them do support both. And then we also define what the event looks like for the structured mode in JSON and Avro, if you're interested in those two. Along with that, we also include a primer, which gives you some guidance in terms of how we expect cloud events to be used, but we also went one step further and tried to explain some of the rationale behind some of our decisions. Because in order to keep the spec really, really simple and as general purpose as possible, we had to really dumb things down. And some people look at us and kind of question why we made some of those decisions, because it may seem kind of limiting in terms of what we did. But if you read the primer, we'll be explaining why we did it. And hopefully you'll see why we made those decisions and why they were good decisions for the long term, right? It's not as complicated as it could be. For example, all the attributes are name value pairs. We don't allow nesting of properties for good reasons. Read the primer and you'll understand why we did that. It makes life a whole lot easier when you dumb things down. We also have what we call adapter specifications. This allows you to see how some events actually might get transformed into cloud events. So for example, for AWS S3 or GitHub and GitLab, we show which bits of metadata from the existing messages should get pulled out into the cloud event metadata. So that if you wanted to write an adapter that converts like an S3 event into a cloud event, if you follow our guidance there, you can do it in a very sort of common way, because the S3 folks and the GitHub and GitLab folks have looked at this and they basically say, yep, this looks right to us, even though they don't formally support cloud events themselves yet, okay? Documented extensions, we basically provide a spot here for people who want to extend cloud events with their own attributes to provide a home for those things. These extensions have no official standing whatsoever. They may change over time. They're not versioned with the spec. It's more like a wiki page more than anything else for the people to work together on some of these extensions. Now, if they become popular, maybe we'll add them to the specification at some point, but we wanted to sort of a testing ground for people to have fun with some new extensions. And then finally, because this is an open source project, we didn't want to put proprietary specifications or mapping to proprietary specifications or protocols into our repo itself. We thought that might look like people were trying to just promote their particular product. Instead, what we allow people to do is to say, okay, fine, if a particular proprietary protocol wants to do cloud events, that's fine. We're all in favor of that. But we don't want that specification that defines the mapping in our repo. What we'll do instead is put a pointer to that specification in our repo, and then they could host that specification themselves outside. So at least allow people to find those proprietary specs, but we didn't want it to look like we were endorsing one proprietary spec over another. So we sort of got out of that business. However, if you're working on a protocol or transport binding that is open source or standards based, then we're more than happy to include it as part of our repo if you want to work on that. Okay. Now, talked a lot about what's in there. Let's talk a little bit about what's not in there, because that's kind of interesting as well. So one thing we purposely avoided was security. A couple of reasons there. One is a lot of the transports already have security built in, so we didn't want to reinvent the wheel. And so that, from that perspective, that you can use what's out there today. But then you might be wondering, well, if you really have all these various hops, how do you get end-to-end security, right? Because point-to-point might be already done, but not end-to-end. Or how do you verify that no one's tweaked the message, along those paths by doing some sort of message signatures and stuff? All valid questions, and there isn't necessarily a great solution out there today. And we may actually tackle that at one point. However, we also acknowledge that trying to solve security problems like that is non-trivial and probably probably very, very controversial. So we wanted to actually produce the spec in our lifetime, right? We didn't want this thing to take years. So we said, okay, we'll leave that out for right now. We may come back to it later, but let's at least get the base spec out there first and see what kind of adoption we get. If it gets very, very popular and people are clamoring for some sort of security story, maybe we'll produce it then, okay? The other thing you won't find in there are sort of what we call transport level metadata. Things like, where is the event intended to go? Who sent it, or where should it be replied to? Not who sent it, but the reply to stuff. That's not in there at all for a couple of reasons. One is that should already be handled by the transport level stuff as well, or already. But also, these are events, okay? These are not messages. Now, events are typically one-way messages that can go to many different people. And when you start talking about replies, then you're getting into business semantics in terms of when replies are sent like that, and that has nothing to do with eventing from our perspective. You can layer that stuff on top of CloudEvents if you wanted to, but as part of a core CloudEvents, that's not what we're trying to tackle. So that's why we left it out. This is just events. We also have SDKs for a variety of different languages. The Go one in particular is used quite heavily in the Knative project. So pick your favorite language, and we help you produce and receive CloudEvents. But obviously, you don't have to use those if you don't want to. Hopefully, your current message processing should just be able to pick up the extra metadata relatively easily. So in terms of status, in May 2018, we became a sandbox project, which just made us a little more real inside CNCF. But in October, we did two things. One, we became an incubator project, which gave us even more authority and more realness to us. But we also released version 1.0 of the spec. So now we feel like the spec is ready to go to be used in production. And at this point in time, we're basically just letting the dust settle and seeing how people feel about the spec as they start to use it. We've gotten lots of great feedback from people who are using it already. They love it, but we want to wait and before we actually tackle the next step for CloudEvents, like security and those things, to see what that adoption looks like first, okay? And however, we're not just sitting back and doing nothing. The serverless working group is looking at what to work on next. In particular, we sat back and said, okay, great. You got these events flowing from point A to point B, but how does the consumer of these events know what events are actually being produced by those producers? Or how do I then subscribe to those events? Can we help out there? And we looked at it and said, sure, let's see if we can do that, right? Let's see if we can work on an event discovery spec so that a producer in a consistent and standardized way advertise what events are being generated for and for what protocols. And then can we standardize how people actually subscribe to those events? How do they specify filters, which event types they want, that kind of stuff. And that's a relatively new set of specs that we're working on. If you're interested in that space, please join us. It's obviously going to leverage CloudEvents going forward as an option because it's a nice fit for that, but it's still relatively new. So we'd love to get your feedback. And with that, I'm basically done. Here are some links for you if you're interested in it. Obviously, the first four are all about CloudEvents, the main site itself and the repos and stuff. If you're interested in the serverless working group, in particular, the white paper I talked about, there's a link in there. The working group also has a sub working group that's working on workflow. If you're interested in eventing workflow type logic, take a look at that specification. It's still relatively new as well, but it's starting to get more and more traction, so you can take a look at that itself. I think they do support CloudEvents, but it's not a proper CloudEvent specification. It's just a general purpose workflow spec. We do have weekly phone calls, Thursdays at noon Eastern. If you're interested, anybody is free to join. And as I said, right now, our main focus is on the two new specifications, meaning subscription and delivery. But if there's other things related to CloudEvents, if you want to bring up or find issues you want to tackle in there, feel free to add it to the agenda. Okay. And with that, thank you very much for listening, and hope everybody has a good day.
Okay, welcome back, folks. Great and excellent talk by Doug Davies. I really enjoyed the CloudEvent talk here. So right now we have some minutes. I think we have 2 minutes maybe for questions, or yeah, 3 minutes actually for questions. So in case you want to ask something, Doug, or Doug, in case you want to say something to the audience. Just want to mention also that Doug doesn't have a video, so you might not see him, just see myself there, which is pretty
Yeah, you don't want to see me.
I can move my mouth as you speak.
Yeah, I've been trying to answer the questions in the chat already. So
cool. So yeah, we're if you want to say something, just go on, and I think that's the right time.
yeah, nothing for me. I already covered everything in the presentation for the most part. As I said, it's a relatively simple spec, and hopefully everybody thinks it is too. For the most part, especially if you focus on the binary aspect, it's strictly additive to your existing workflows or message flows, and that was our main point here. Keep it as simple as possible.
Awesome. Thanks again for joining us, and yeah, I think this is something that we should continue, both of us, both communities, right, to keep working together, or to start working even more together, right, so people understand the benefits of each other, of each of the other specifications, and yeah, looking forward for that feature.
Yeah, look, I'm looking forward to some areas of collaboration as well. It'd be a lot of fun.
Thank you. So now we're going, as always, with a little bit of with a little break, so you can do your stuff and watch our awesome sponsors, and we'll come back with Keen's presentation in a few minutes. See you in a bit. All right, folks. Next up is Kévin from Postman, and he's going to be talking about joining, like using all the specs together, right? Like OpenAPI, AsyncAPI. I even lost the count. API, like Postman collections and lots of the different specs. By unifying them using APIs.json. I think this is an interesting talk. So I hope you folks enjoy, like I always do, watching Kévin speak. Enjoy.
Hello there. Welcome to the AsyncAPI online conference. This is pretty cool. My name is Kévin. I'm going to talk to you today about a Slack API index, which is a mix of OpenAPI, AsyncAPI, Postman collections, and ALPS, all indexed using APIs.json, which we'll walk through each of these specifications here shortly and show how they all can work in concert. This whole presentation is meant to be an interactive presentation that anyone can experience. So the URL is here. I'll make sure it gets published as part of the show notes so that you can come here and walk through this as well. Let's get going. So first of all, I'm the chief evangelist at Postman. If you're not familiar with Postman, it's a HTTP client that in the last couple of years has matured and evolved to become a full-blown API platform. We have 10 million developers, and you can use Postman to make API calls, save them as collections, build tests, documentation, mock servers, and a whole bunch of other things. But I joined Postman about 6 months ago, and I'm the chief evangelist helping enterprise organizations think about the API lifecycle and get more organized and strategic about how they do what they do. Some of you might also know me as the API evangelist at APIevangelist.com, where I've covered the technology, business, and politics of APIs for the last 10 years. I started the blog back in 2010, and about 6 months ago, I joined Postman, and while I keep working on the blog, I'm just continuing my work on the API lifecycle and working with enterprise organizations and talking to Postman customers. So to show how all of these specifications work together, let's start with the OpenAPI, which really is the most ubiquitous and oldest of the specifications I'm going to talk about today. Slack maintains their own OpenAPI specification. You can find it on GitHub. And I've taken a subset of this API definition for this presentation. It's actually, the full Slack API is pretty big. So I had to trim it down to just some around conversations using Slack. So let's walk through OpenAPI before we get to the other specifications to kind of connect the dots here and see what they're all about. So OpenAPI begins with an information block that gives us the title and description of the API. We're profiling the Slack web API here. So this is the HTTP API that you can use to interact with the platform. The info block has contact information and whatever version we're at with Slack. That gives us a server block that gives us details about where we find the base endpoints for the API, as well as Slack gives us auth endpoints. I've seen other providers provide mock, staging, and other sandbox or regional-based APIs as part of the server definition. Well, the OpenAPI gives us details about the path, each of the individual paths that are available for an API, including the HTTP method, whether it's a get, post, put, delete, or other type of HTTP verb. Each HTTP method gives us a summary as well as a full description of what that API can do, providing us with as much details about what you can do with that individual HTTP method when integrating with the Slack API. Also gives us details on parameters. You can describe header, path, or query parameters using this object. So you can describe the name, what type it is, where it's in. It's in the header, the path, or in the query. You can provide a description as well as schema and other details about each individual parameter. You can also describe the request body and details about if it's a post or a put, that you can pass, what type of information you can pass in. In this case, it's a form form, and you can submit channel information. And so this gives us the details of the request body and what's expected when it's being submitted. You can also find the responses. Hopefully there's more than one, but there should at least be a 200 status that gives us the details of what we can expect when we make a successful API request, giving us the details of the response, including a reference to the schema, which you can see we can expect back an application JSON schema, and it gives us the reference to where we can find it. This reference provides us with a reference within this document that helps us see the entire object that we can expect to get back, giving us details of what's required, the properties, and other schema data types, examples, and things that go with those properties, helping us understand what's expected back as part of each response and what should be included as part of each request when we're working with each of these individual API paths. So OpenAPI is formerly known as Swagger, is pretty widely known to be for documentation. That's its #1 use, so why you want to create an OpenAPI definition. It provides all the common details you would need to document the API for your consumers. But it's used much more for that. Beyond that, you can use it to generate mock servers, use it for testing, many other things that you can accomplish with it. But it really helps to have a up-to-date, robust, complete enough OpenAPI definition that you can use for whichever stop along the API lifecycle suits what you're trying to accomplish. So after OpenAPI, AsyncAPI is the next most widely used, fastest growing, widest tool base API specification out there. So OpenAPI started in around 2010, 2011, and became, about the time it was becoming OpenAPI, AsyncAPI emerged to kind of augment and act as a sister specification for OpenAPI and help us make sense of the beyond HTTP with pub/sub, event-driven, and message-oriented APIs, giving us a new specification that we could use to describe the APIs that we're building. So like OpenAPI, it uses a similar pattern and provides us with an information block, giving us a title and description of the API, contact information, terms of service, and what version we're dealing with. So you also get a servers block, but you get a little bit more detail here with AsyncAPI. You get the description and the URL. You get some variables that can be passed in, but more importantly, you get a protocol property that allows you to define if this is HTTPS, if you're going to switch to WebSockets, if you're going to be using TCP, MQTT, or other. It allows us to define the servers that are behind each of these APIs, going beyond what OpenAPI can do with HTTP alone. It helps us define, AsyncAPI helps us define our channels that users can subscribe to or publish to. And Slack provides us, similar to the paths we have for our OpenAPI and our request and response, Slack gives us a variety of channels that we can subscribe to when it comes to staying in tune with activity on Slack. Each of these channels is given a basic summary, helping us understand what actually each API does. Allows us to tag and organize our APIs, and then describe our payload by providing references to the schemas that a consumer can expect to get back when they subscribe to one of these channels. Similar to OpenAPI, it uses references as well as JSON schema to define these payloads. So the Slack API does not share a common schema between its request and response and its event-driven API, but you can, because it's both JSON schema, you can share schema across your HTTP and your TCP and other APIs. So it allows you to define your schema using JSON schema, have those either stored individually as files as well as within your AsyncAPI or your OpenAPI, and referenced and used as part of the request response payload for these APIs. Gives you a much better control over the JSON schema and how you're using it. So it gives us the full details of what can be expected as part of each payload, just helping us get more organized about how we manage our schema. So just like OpenAPI, AsyncAPI can be used to generate documentation. It's definitely one of the biggest benefits is to have it make the API more tangible, more useful, and keeps your documentation up to date and consumers in sync with what's happening and what's needed to get going. But like OpenAPI, you can use that AsyncAPI specification for many other stops along the API lifecycle. You can generate your docs, your mocks, you can generate tests, and do many other things with it that you will encounter as you're trying to develop and support your API. So next up, after OpenAPI and then AsyncAPI, let's take a look at Postman collections. So Postman collections are an open source format from Postman that, similar to OpenAPI, allows you to describe the surface area of your API requests. You can generate Postman from OpenAPI. You can import your OpenAPIs using the Postman client and generate and output Postman collections. Postman collections provide you with an information block similar, allows you to give it your collection a name and a description, helping understand what this specific collection is for, what it does beyond the OpenAPI definition. Like the OpenAPI, it provides details of the request. It has your auth, your HTTP method, the headers, your body description. So it has a lot of the same elements that are present in your OpenAPI definition. But if you look, we actually have values for our headers in this one, and we can actually provide the details of our body and actually make specific API requests to our API. So we can build collections that actually carefully craft specific requests we want to make, or a series of requests we want to make in a specific order with certain information. So we can actually interact with Slack and actually make one or many API calls with specific values using the API, using these Postman collections. So once we have a collection defined, either making a single request or a series of requests, we can use those within Postman to actually run them as monitors, scheduling them using different cloud infrastructure, setting them to run at different intervals, and scheduling and automating the execution of these specific collections that have a specific business purpose. We can run them as runners manually, and then we can export them and use them in CI/CD pipelines using Postman's open source Nauman runner. So the collection itself, as well as the runner, are both open source, and you can execute those within your infrastructure, or you can use the Postman platform to actually scale those and execute on them. Next up after Postman is ALPS. ALPS is a format and specification for defining the semantics and actions that exist across an API platform. So I've auto-generated this ALPS document from the OpenAPI. So what it's done is it's gone through and taken all of the properties from all my schema objects and organized them so that I have a list of all the properties that can be applied across API operations, or this specific set of APIs. Then using grouping, I can group these. So I'm grouping them similar to how I have my objects defined in my JSON schema. But ALPS gives me a much looser way of defining the properties and the semantics of how I'm using my APIs, allowing me to, yeah, this is a specific object. It's a history success object, but it allows me to more loosely organize it in the way of a specific action that's going to be taken. I'm adding something, I'm updating the basics, but the semantics of that are probably greater. So ALPS allows me to define that in a way that is a lot more flexible. And then I can associate that with specific actions that are either safe, idempotent, or unsafe, depending on whether it's a get, a post, a put, or a delete. But this really starts defining, allowing me to get beyond just my CRUD and kind of my caveman vocabulary of my OpenAPI and actually look at the actions that can be taken across. This particular one is generated from the OpenAPI. I'll be doing the same from the AsyncAPI, creating one single ALPS. Maybe I'll create two separate ALPS documents, one for each. But it'd be nice to have vocabulary across both the request and response as well as the event-driven API. So all of this allows me to visualize and document and better understand the activity that occurs across API platforms. So ALPS for me is very much what's possible. Here's the actions that can be taken. I can then, marry that with an HTML kind of my web strategy, and actually develop forms, buttons, and other action enabling embeddables that I can use across my applications and use across the web. And then, this helps me really start defining not just actions that can be taken, but the events that occur as a result of those actions. And so this gets into the event-driven side that Async API brings to the table. So I'm hoping that ALPS is going to be be that bridge. If you think of it, schema.org is the different objects, the common objects, and the vocabulary for those objects. I see ALPS as being that similar common vocabulary, but for the actions, the verbs, rather than the nouns. So this really helps me understand the real-time event-driven nature of the landscape using an artifact that helps me see that. So lastly, the final document or artifact that we'll have in here is called APIs.json. APIs.json is a specification that I developed with my partner in crime, Steve Wilmot from 3Scale, but now Red Hat. And it came out of work that I did for during the Obama administration for a data.json file for federal government data. So you could find data.json files in the roots of top-level cabinet agencies' websites, and it provided a machine-readable inventory of their public data assets. So after leaving DC, I needed the same for APIs. I needed a sitemap.xml for APIs, and we created APIs.json. It's still in its early versions, and we're going to do some more work on it. But this one here is an index for Slack, providing us an index of Slack API operations. So similar to the other artifacts, we've got a name and description of this collection. rather than the API itself, whether it be in the web API or the event, this is the API operations. This is Slack. This is what Slack does, and its image, logo, and then it has tags and when this index was created and when it's been modified last. So this base core set of info describes this collection of APIs, this platform or operations. And then it gives us an APIs object array that we can put many different APIs in here. For the Slack, we've got two. We've got the web API as well as the events API. For the web API, we have a description, an image, and a set of tags that describe it. But more importantly, we have a set of properties, and these properties have a type and a URL. And in this case, it's an OpenAPI spec. So it's the OpenAPI spec that we just looked at the beginning of this talk. It's a reference to that OpenAPI saying, hey, for the web API, here's the OpenAPI definition that you can process. We also have a Postman collection property that gives you the URL for the Postman collection, allowing you to pull that in and put that to use. We could have multiple Postman collections accomplishing different business objectives, and they can each be indexed here as part of the Slack API. And then we've got our ALPS definition. So this gives us the vocabulary for the web, the actions that could be taken as part of the web API, providing us with three pretty key indexes of machine readable artifacts for the Slack web API. Allowing you to pull it as part of this API's JSON, but then pull those formats using these properties. If we jump down to the web API or the Slack events API, excuse me, we have an individual JSON schema. They provide the common event wrapper schema for their events API on GitHub. And so we have an actual JSON schema file all by itself, indexed here for use outside of the AsyncAPI that's also included here. So we have a full description, a reference to the AsyncAPI for the Slack Events API, providing the details of this API alongside the details of the web API above. We also have a set of common properties. So these span across both all the APIs being offered as part of this Slack API collection. It gives us URL types and URLs to some common human readable references as part of the Slack API operation. So the ones above were machine readable artifacts. These ones ideally would be machine readable artifacts, but they just haven't matured along. Okay, actually, a couple of them are. Look, if you look at the blog RSS, that's a machine readable artifact. And if you think about it, references to Twitter or GitHub, because they have APIs, technically are also machine readable artifacts if you have proper authentication. The goal here is to provide the common building blocks of the Slack API operations that you might want to put to use as a consumer. And so this is all indexed as part of a common set of properties that can be used. And then lastly, the API's JSON describes who's the maintainer in this situation. So this particular, this particular API's JSON collection is maintained by me. Slack didn't create it. So I'm actually curating it and managing it. And so I'm listed here as the maintainer, and it's got some basic contact information for me. So this API's JSON can be used to drive, reference cards, website listings, anything. Pulling that API's JSON, plugging it into your React or other single page app, and then you've got an index for an API. So here's a card that lists the name, the logo, the description, as well as some basic getting started, details that most people are going to want with an API. You can pull the common properties and show legal and support and other information that developers are going to want to get at. You can show these as icons. There's just many ways to pull the API's JSON information and then display it. You can make, external resources available, show the GitHub, Twitter, Facebook, YouTube, the bulleted list, there's a set of icons, provide access to the status and transparency board that Slack provides, and then their security overview page. So this really starts indexing and making available really important links as part of the Slack API operations. But this can be embedded on any site and any documentation used across social media, and then quickly, make the API more accessible, as well as extending the reach and the network of that API using APIs.json. And so hopefully all of this kind of shows, how multiple API specifications can work together to help us map out the landscape across our API operations, as well as map out the landscape that exists on the open web. So I use these to describe APIs that I find across the web. I use it for Slack. That's why I have this one. That's why I created it. You can see OpenAPI strength is allowing me to describe the surface area of the HTTP APIs that I'm profiling. It gives us all the details, in this case, of the Slack web API. AsyncAPI allows us to go further and describe pub sub message, and allows us to get beyond the HTTP protocol and look at TCP, MQTT, and start describing in a consistent way, in a way that's consistent with OpenAPI, describe the surface area of those APIs. So between OpenAPI and Async, we've got pretty good coverage. But then Postman comes in and allows us to execute on specific actions, specific requests that need to happen across the HTTP API. And so we can craft individual Postman collections that help us realize specific business scenarios, specific workflows that we need to test or document, and define those as individual collections, and then run and execute those as part of a schedule or as part of a pipeline, and accomplish specific things around our request and response APIs. And then, of course, JSON schema is used across OpenAPI and AsyncAPI. Postman uses it to validate Postman collections, and that JSON schema allows us to just define the underlying schema for our API infrastructure. And then ALPS is hopefully going to allow us to really define, well, what is that action vocabulary that we have available to us. We have all of these nouns described, and how do we describe what the potential is? What are the actions that can be taken? Not just the CRUD, the create, read, update, and delete, but what are the actual meaningful actions that can be taken across both these APIs, and what can we subscribe to? And then the flip side of that is really, what are the events, the outcomes of those actions that can be taken? And that's really the event-driven side that AsyncAPI lets us describe. So my hopes is that ALPS is going to help us be this bridge in rapidly mapping what the actions that can be taken, what are the verbs that exist across our request and response structure, as well as our pub, sub, and event-driven. But then how do those translate into meaningful events that we can tune into the signals from? And so JSON schema and ALPS really helps us just get a handle on our vocabulary and what's going on. And then APIs.json wraps all of this and provides us with an index of all this machine readable goodness, as well as the other human aspects of API operations that aren't machine readable yet, but are going to have to be if we're going to do all of this. So my goal in doing this presentation, this talk, is to really show folks that there's not one spec to rule them all. It's good that there's multiple specs out there. I know there's a lot of talk of AsyncAPI replacing OpenAPI, or what's more realistic, what's the future. And having, I don't even have RAML, I don't have API Blueprint and other viable API specs listed here. And my point is these specs should be able to live in harmony. They should be able to work together. They have strengths and weaknesses. There are some overlap between them, but they have distinct purposes. And if we're aware of them and we use them well for those purposes, and we have them indexed properly, that we can get more organized about this. I'm seeing other specs emerge, like one for monitoring and service level agreements coming out of Spain. And so I'm seeing other ones emerge like that are help out with specific stops along the life cycle. I'm seeing specs for just security. You can look at what 42 Crunch is doing, and their security artifacts are pretty compelling in what they've done with the OpenAPI. But both of those should, in my opinion, not live just within OpenAPI and bloat that spec. They should live outside of it. They should either be a sister spec or an overlay and augment what's going on and be able to stand on its own, similar to JSON schema as its own individual artifact. So hopefully that whets your appetite as far as what's possible when it comes to API specifications. I'm really excited still about OpenAPI after working on it all these years. Really excited for the opportunities with AsyncAPI, and then now being part of Postman. And we're going to do some more work on APIs.json and hopefully bring it up to a version 1, something that's a little more stable and usable that people can put to work. Anyways, I'll take questions, and I'm happy to talk to anybody about these specs. And you can reach me anytime. Just look for Ken Lane API Evangelist. I'm pretty easy to find. All right. Well, thanks, everyone.
Okay, folks. So we're back after Ken's talk, and I would like to remind you that so Ken has been around, as you see on the chat. But we'd like to remind you that after the talks, so feel free to ask questions to the speakers. So also thanks Kim for joining us and being with us here today in this crazy idea that we have, pretending that we are professionals with video live streaming. And yeah, thanks for that.
Thank you. Happy to support anytime.
So. Let's see if anyone has some questions here. I think you've been responding pretty much all of them, right? Most probably. Let me check. Okay, cool. So is there anything else? We don't have so much to say right now, unless someone wants to join and jump in and ask something. So is there anything that you want to add or something that you would like to explain verbally of one of the questions that you got on the chat?
No, I mean, I'd just like to leave it with the point that, it wasn't just about these specs. Really what I'm trying to set up here is there's not going to be one spec to rule them all here. And I really support the specs working together. I really support new specs coming along. And as long as they have, specific purposes and value. So I think that's what folks need to keep in mind as they long for that one spec to rule them all. Just acknowledge and realize that they all work together. And if you want to learn about any individual one, they all have their own GitHub repo, so you can participate and get involved with the collaborators. I know Fran would love it if you made some pull requests on the GitHub repo for async. So get involved.
Thanks, man. So I would just love to mention that King has been a great supporter from the early days. And as Emmelyn said on the chat, she heard about AsyncAPI thanks to him. So thanks again, man. And thanks for joining us today. Next up is Marc DiPasquale, but we're gonna jump into a quick break to show the logo of the sponsors we are very happy that they're supporting us, and also for you to make a quick break. See you in a few minutes.
Hello, back again. We had a shorter break, and now the next talk will be from Marc, and it's going to be about the design to code using AsyncAPI. But before we jump into this talk, during this whole conference, I noticed something that people write about in the chat, so I spontaneously want to mention something. I have an impression sometimes when people think about communities and open source projects that they feel they can only contribute by submitting pull requests. While it's not really true. You can support any community by just giving a simple, really simple one-word advices. And I'm mentioning it now because Marc actually is not only a presenter during this conference, he also joined us in our Slack to also share some advices about the event. And he made one really simple statement, like asking us a open question, like, aren't we afraid of issues with the connectivity of a live event? And then like me, Eva, and Fran, we started discussing like, yeah, maybe we should actually do recordings. And then that's how we actually started thinking about this whole async way of doing the conference recordings and speakers at the same time answering questions. And it all actually came, this great idea came from this like simple contribution to the community from Marc. So thank you a lot, and enjoy the talk from Marc as well.
Hi, I'm Marc, and I'm a developer advocate at Solus, and I'm excited to talk to you all at the first ever AsyncAPI Conf. So thank you for having me, and let's get started. My talk is going to be on from design to code using AsyncAPI. So I'm going to start off by going over a quick agenda here. So I'll give a quick intro where I'm going to talk about the value of real-time data and the challenges that come with it. I'm then going to introduce you to the PubSub Plus event portal, and I'll talk a little bit about some COVID-19 data streams. We'll then use those COVID-19 data streams as part of a live demo. So I'm going to use the PubSub Plus event portal to extend an event-driven architecture to add a stream processor that will process some of those COVID-19 streams. And then I'm going to leverage AsyncAPI and its code generators to generate a Spring Cloud Stream microservice and actually process events in real time. So first, to start off, I think some of you may have seen this chart before, but studies have definitely shown that data is more valuable the sooner you use it, with it being most valuable, in real time within seconds of a change in state occurring. So historically, what we've seen is a lot of batch ETL, where you periodically get a bunch of state changes at once. You extract, transform, and load them into some sort of data store, and then do historical analysis on that data. So that's getting the least value out of your data. You can, of course, get more value out of your data by following what I would call a store and query approach. So in this approach, as events occur, you would actually take them, process them, and store them in a data store, and then you'll have applications that will query the data when they need it. So in many cases, a REST API is used for this. But to get the most value out of your data, you really need to become event-driven. Your systems need to be able to subscribe to events that they want to know about, and then as those state changes occur and events happen, your systems are notified and receive those events in real time, allowing you to process those events and act on the information while it's still most valuable to your business, to your organization. And this is really the goal that many companies are trying to achieve by going event-driven. So the question is, if we want to be real-time, then why are we not? Why are organizations not taking advantage of this? And so the answer for that is because it's not easy. Being event-driven is not easy. So only organizations that have actually had to become real time have been doing that. So this diagram is actually a real diagram, and it's an example. It's a architecture of the FAA's National Airspace System. And so they had a need to be real time because they need to know, exactly where the planes are, whether they're in the air or on the ground. They need to be alerted of weather phenomenons as they occur so they can make changes and keep people safe. And so many more use cases exist throughout this domain and are factored into this architecture. So this diagram is actually, it's a real diagram. I believe it's actually a Visio diagram. And so you can imagine trying to implement this system is not easy, and let alone after somebody else has built the system and coming in as a new developer or a new architect and trying to determine where changes need to be made, or if you're making a change, what else is being affected is quite difficult. So, why is this the case? And so the reason is there are a lot of reasons that it's hard to build these event-driven applications. And it's really the who, what, when, where questions that need to be asked. So where do you discover what events are available for reuse? Why does an event even exist in the first place? What topic do you subscribe to receive it? What changed? How do you determine the data structure of the payload once you know that the event actually exists? Who should have access to it? So in many cases, there are security concerns about which systems can access certain data and which can't. So you want to make sure that you have those security rules enforced in your operational system. Who made the latest revision? So if something broke, how do you know who made the last change? Who can tell you more about it? When you're not sure, when you have such a complex architecture, when you're not sure if a certain event is something that you want, who's the owner of that event? Who can I go talk to? Who can I check with to make sure to hear about when the next version is coming out? Is your change backward compatible? If I make a change, which systems might I break? And again, who is impacted by your change downstream? And also, does it comply with your security policy? So all of these questions are hard, and you really need tooling in order to make this easier on developers and architects. And so in the synchronous RESTful world, there's a few solutions that help with this. So OpenAPI, the OpenAPI initiative is an open source initiative that provides a specification to define your RESTful synchronous apps. It also provides Swagger tooling to help generate code from those specifications, from the documents that specify an app. But also there's all of these other things that you still need to do. So that's why open API management platforms are available. And so these API management platforms provide an API portal that allow you to really document your applications, register the applications for governance reasons, analyze what's going on so you can continue to improve and to monetize your solutions. They also allow you to participate with your community and collaborate, across development teams, developers with architects, vice versa, to really design and implement your solution. And then of course, they allow for better productivity by using tooling such as Swagger to do code generation. So this tool set between OpenAPI and API management platforms really answers the who, what, when, where, why, and how for RESTful APIs. But eventing and event-driven is just different. The event is really the interface. Applications are decoupled. So the challenge is different, and you can't use an API management platform to solve the event-driven, the who, what, when, where for event-driven architectures. So where do we go from here? Well, as you probably guessed by the name of this conference, AsyncAPI is providing part of this solution. So AsyncAPI is, of course, it's kind of risen as the industry standard for defining your asynchronous APIs and event-driven APIs. So it provides not only a specification, but it is also providing code generators. So you'll be able to define your application, as you can see on the screen here. So on the right, this is a YAML representation of a AsyncAPI API document where you have your version, you have information about your application. You have the different channels that in this case it is subscribing to, and the schemas that define the message that it's going to receive. But you need more than just a specification and code generators. So like we have the API management platform for the RESTful world, we need an event platform for asynchronous interactions. So to answer the same types of questions, right? So we need an event portal to document, register, analyze, collaborate, and to have better productivity. So we have AsyncAPI, both the specification and the code generation that I just talked about, to help with this. But the platform itself has not been available until now. And so Solace has introduced its PubSub Plus event portal. So this event portal is really the equivalent of the API portal, but for the event-driven world. So it is a single place for architects and developers to go to design, to create, to catalog, visualize, discover, and share all of your events across your architecture. So now with the event portal available, we can have a similar experience as we have in the RESTful world. So in the RESTful world, we have the API management tool, and it can output, it gives you a specification, an OpenAPI document defining your app. You use Swagger tooling to do code generation. You get generated code, and your apps communicate usually using HTTP. So now with the PubSub Plus event portal, you can use that to manage your entire event-driven architecture, and then use AsyncAPI, the AsyncAPI specification to document your apps, and use AsyncAPI code generators to generate event-driven code, and of course communicate over a whole bunch of different runtime protocols, like AMQP, MQTT, and there's other open standards and out there and available. And so this is really what I want to demonstrate for you today. So I'm going to show you the event portal and talk about some COVID-19 data streams, and then we'll design an app, export a specification, and do some code generation for a Spring Cloud Stream microservice. So before we jump into that, just a little bit of background information here. So in the event portal, you really need to know about 4 different things. So an application domain, which really allows you to define your different software development teams or lines of business, or however you want to organize your development teams. Of course, the applications themselves, whether it's a publishing application, a subscribing application, or both. An event, so an event is defined by that Pentagon icon. And so an event has a topic address, but also metadata that will reference a payload schema. And then lastly, the 4th is the schema itself. So the schema could be a JSON schema, an XML schema, or of course you can define your events in many other ways as well. And so all of those things will be connected in the event portal, so you can really visualize your architecture, and it's an interactive graph, so you can zoom in, zoom out, move events around, and really have a better experience understanding your architecture than, for example, the Visio diagram that we saw earlier from the National Airspace System. So let's check it out. So if I come over here, this is the GitHub repo that has the COVID stream processing information in it. So this is publicly available. Solace is actually making this data available for free for anybody to use. So we're getting data from the COVID tracking project and from Johns Hopkins University. And essentially, we're taking it from those data sources, publishing it into Solace PubSub Plus, and allowing anybody to create client applications to receive that data. So that's what we're going to do today. So I'm going to go into Solace Cloud and log in. So Solace Cloud is where the event portal lives. So once I get into Sol's Cloud, I'm going to jump into the designer here, and we're going to look at the COVID data feeds. And so in the COVID data feeds, we really have a few different things going on. The first up here is the Johns Hopkins data publisher. So this is getting the Johns Hopkins data, publishing it out, and it's received by a cases regional splitter and a cases splitter that split the data on different things and make it available in different streams. At the bottom, and what we're going to use today, is information from COVID tracking. So we have a state's current value publisher that queries their APIs, gets the latest information, and publishes it every 30 seconds or so. We then have a state splitter that is processing that data and splitting it up by state and actually only publishing events when changes actually occur. So this allows anybody to subscribe to these single state current data update events and only get notifications when things change. So, you know, if things stay the same for 5 hours, you don't just get a bunch of events that mean nothing for 5 hours straight where the state stays the same, but instead you'll get an update after 5 hours that says, hey, you know, the data has changed for Florida, now you can process that. So you save on network bandwidth, you were notified in real time when something happened, and now you can process that event and take action. So why don't we add an application here. So if I click add an application, we'll go ahead and name this application COVID tracking state test percent calculator. And so what we're going to do, I guess I'll show you real quick. This is an example event that comes out on a topic. So we've got COM COVID tracking test states, current update, and then CT for Connecticut. So the data that comes out has a whole bunch of different things in it, but a few of the things are the total test results, how many of them were negative, and how many of them were positive. So what we're going to do is take this information and we're going to calculate a percentage for each state. So because this data is specifically for the state of Connecticut, we'll receive the event. Of course, we'll receive events for every state, but we'll process them, you know, one at a time as they occur in real time. So we'll say, all right, well, what we want to do is provide a new event that will just publish the percentages. And so what that event might look like is something like this. So it might have the state in it, the total test results, the date checked and the date modified, how many cases were positive and negative from the tests, and then the percent positive and the percent negative. So that's really what we want to create. So I generated the schema here, and so I'm going to go ahead and copy that. We might use that in a minute. So let's bounce back over here, and we'll describe this as application that calculates and publishes negative and positive test results with percentages. All right, and I'll add myself as the owner. And then I want to subscribe. I want to manage my events here, and I really want to subscribe to the COVID tracking single state current data update event. So I'm going to select that event and then click save. And so we can see on the graph here, we now have our new application. It's subscribing to the single state current data update events. But what we also want to do is publish a new event. So if I come back in here and I say, you know what, I want to add a new event. So we're going to say COVID tracking single state, because we're only going to send it out for single state at a time, test percentages update. And so we're going to say event that contains percent positive and negative tests. And we want to publish it on this topic. And so now we need to add our payload schema as well. So if I click add a new schema, Let me copy a few things in here. So we're going to name our schema. It's a JSON schema, and the description is going to be event with test results, including percentages. So now I actually need this schema from before. So we'll throw that in here and we'll click save. Oh, percent data 2. So we'll click save on that. We'll save our event. Must have already had these events from before. So we'll do 2. All right. So now that we have that event, it's marked as new. So we want to publish those events. So we want to add that as events published and click save. So now we can see in our little graph here, we are now publishing that new event. And so now as a developer, I want to actually develop this application. And so I have all the information in my design. I collaborated with my architect to make sure everything was accurate. And now I can obviously code this from scratch, but I don't want to code it from scratch. I want to use AsyncAPI code generators. So I'm going to go to AsyncAPI here, choose the YAML, and click download. And what this actually did is exported an AsyncAPI document. And so in here, under components, it has a bunch of different schemas. So we've got our 2 different schemas, one for the input data, one for the output. We have the messages that our application expects to send and receive. And we have the channels here defined that we're going to subscribe to receive the events coming in and publish for the events coming out. So there are a few things that we're still working on with the code generator here as part of the AsyncAPI community. One of those is it doesn't yet support dynamic topics. So I'm going to go ahead and get rid of the dynamic piece of this topic. And there's an extension, XSCS function name. And so what this will do, let's call it calculate percentage, is it will correlate these channels together. So when I subscribe to this channel and receive an event on there, my application is going to expect to publish on this channel, kind of one event in, one event out. I'm building kind of a stream processor here that's going to do that. I also want to create a destination name here, XCS destination. So I'm going to use the solace binder. So by using this, it will actually create a queue for me to make sure that I queue up my events. So if I go offline, I'll still have them to consume later. So I want to do calm COVID tracking, and then let's see, I'll call this calm COVID tracking, and then calculate percentage.q. Why not? That should work. So I'm going to go ahead and save this document. So now we need to do code generation. So let me bounce over here to the terminal. I'm in the temp AsyncAPI conf directory, which is empty. And so let me copy a generation command over here so we all don't have to watch me painfully type this. And so make it a little bit bigger so you can see my screen. Oops, clear. Make it a little bit bigger, fit to screen, paste the command. All right, so this is using the AsyncAPI code generator with the Java Spring Cloud String template. So let me actually show you the template real quick. We're using this template here. And so this is as part of the AsyncAPI GitHub org. You can find it in there. And what it does is it's going to take in an AsyncAPI document and output a Spring Cloud Stream microservice. So you can look at here and see, how it works, how it knows what methods to create, what they're named, how to use the template. So all that is here, as well as some different parameters to specify. So for this in particular, I'm outputting to a COVID tracking test % calculator directory. I'm using the Solace binder. I want the actuator to be included in my Spring project. It is a Maven project, so we're going to specify an artifact ID. and a group ID. I'm specifying the Java package. So the generator is going to take the schema for the objects that were included in the AsyncAPI document and actually generate POJOs from those. And so those are going to be placed in this package. I then am specifying, because I'm using the Solace binder, I can specify my host, my username, my password, and the message VPN. So this will actually configure my connection information for me, so I don't have to worry about inputting that after. I'm then pointing here at my AsyncAPI file. Let me actually make sure it's the right one. Tracking state test. So I think this is the one we just edited. And just make sure that it's correct really quick. COVID tracking state test %calculator.yaml. Correct. All right, and then I'm putting the template at the end. So I'm going to let that go and run. And hopefully here we'll get success. All right, perfect. So my Shiny files are located here. So let's go ahead and import those into my IDE. So if I say import general, actually, no, I want Maven. It created a Maven project, so I want to do existing Maven project. Hit next. And then hopefully here, if I go to browse, temp, AsyncAPI conf, I hit open here. Cool, there's a POM, so I hit finish. And so I'm using the Spring tool suite, so it'll actually recognize this as a Spring project and give me some niceties to go with that. So we've got a red X, but that's okay, we're gonna fix that. So here's what we generated. It's a regular Java project. We can see everything's under our package that we specified. We have these two classes here, the COVID tracking state current data and COVID tracking state current test %data2. And so these objects were generated. And so everything's all nice and in here. We've got everything that was in the schema. We've got getters and setters so we can access the data. So now we can go ahead and just use this to code up our app. So application.java is really where the function, where you write your actual business logic. So we come in here, we basically have an add business logic. And so what we want to do is we don't want to return null. We want to return input. We're going to calculate the input. And so the input here in Spring CloudStream is actually defined by this object here. So we're taking in the state current data and we're outputting the state current test %data2 object. So what I want to do is say, I want to create a new one of these. So output equals new. Return output. So the output object is what we actually want to create. So as part of this, what we probably want to do here is get the state that the data is for. So if we say input.getState, we can get our state. Why don't we print this out? System.out.print line state update received for that state. All right, and then what we want to do on our output is start to set our data. So output.set the date check. So we'll take the date checked from the input and put that in there. Set date modified. Again, we'll get it from the input. Set the number of negative cases from the input. And the positive cases. So I'm just populating my new event, right? And so you'll notice here that as I type, I'm just putting my business logic in here, right? I didn't have to wire up any messaging stuff, and the reason for that is Spring CloudStream abstracts a lot of that from you. So this is just a regular Spring bean, which is awesome. It's really the benefit of using Spring CloudStream. I don't have to go learn how to use the Solace APIs or the Kafka APIs or the Rabbit APIs in order to become event-driven. It's really easy on the developer. So I want to do that, and then just to take a little bit of a shortcut here because I'm running low on time. Copy some code I have on the other screen. So let's delete this. And so essentially what I did here was add, I calculated the % positive and the % negative just by dividing the number of positive cases by the total test results, and the same for negative. And then I'm going to print it out. So the last piece I wanted to look at real quick before we run the app is actually the application.yaml file. So this is where all the bindings in Spring Cloud Stream goes. So this was generated from the AsyncAPI document and put straight in here so the developer didn't have to care. So it actually specifies our function, the bindings, and how they bind to the different topic destinations. And then they even put it in all our credentials here to connect to the event broker. So now that we have that, we should be able to just run this as a Spring Boot app because Spring Cloud Stream is based on Spring Boot. And let's see if my Mac has enough memory to continue running. There we go. All right, so it's a Spring app and it's running. Oh, I need to make one quick change to it actually. Remember earlier I mentioned that the application doesn't yet support dynamic topics. So I just need to put in a greater than here to say subscribe for everything. I'm also, so we don't have to sit here and wait for updates to happen, I'm going to subscribe to a test stream here. So let me make those changes and then run this again. So now it all started up, it connected to the event broker, and pretty soon as events come in, we should start to see them be processed. So I think the test events happen every 30 seconds or so. So let's see. But so while we wait for the events, I just wanted to point out, how this can really improve the event-driven experience. Oh, there we go, we're getting events. But you can see how quickly we went from design to code. And this was all because of AsyncAPI and the ability to use the PubSub Plus portal. So that's all I have for you. I want to say thank you. Thank you for watching the talk. Thank you for sticking with me the whole time and watching my horrible coding skills as I typed everything out. If you want to check out any of the resources that I used, I've added some QR codes here on the screen, so feel free to scan these with your phone. The first is to try the PubSub Plus for free. So this allows you to use the PubSub Plus event brokers and also check out the event portal that I used for the design portion. The middle here is the COVID-19 event stream GitHub repo. So these are the event streams that are available for free for anybody to use. And let's see what you come up with. Let's see how we can help people analyze the COVID-19 data and improve things for everybody in this time of need. And then also on the right here is the AsyncAPI Spring Cloud Stream code generator template that I used. So again, thank you. Enjoy the rest of AsyncAPI Conf. Have a good day.
Okay, we're back after the presentation from Marc, live with Marc, competing with our virtual backgrounds. Thanks a lot, Marc, for your presentation and showing how you're also helping fighting the COVID-19. We have less than a minute, but at least that, and the stage is yours. Would you like to add something to your talk or maybe answer some question that was not answered in the chat?
No, thank you. Thanks for having me on the first AsyncAPI Conf. It's an honor to be here. I will say, I think I got to pretty much all of the questions in the chat, but feel free to reach out to me if you have further questions on the AsyncAPI Slack org or on Twitter or LinkedIn. I also want to give a shout out to Michael Davis for creating the Spring Cloud Stream generator template that I used during the demo. That's all. Thank you.
Thank you, Marc. So we're gonna have a short break again. until the next presentation from James. And now we're going to show the logos of the great sponsors that sponsored the event. Thanks.
Okay, so we're back from this small break that we did just now. And next up in our agenda is James Higginbotham. And I'm honored to introduce him because I have a special, I have a special feeling for James because he's been really supportive with AsyncAPI since the real beginning. And he's been doing really good contributions and advice and really good things. So yeah, like I just said, let's have James Higginbotham and enjoy his talk.
Hello, welcome everyone. Today I'm going to be talking about event-based API patterns and practices. My name is James Higginbotham. As was mentioned in the introduction, I'm an API architect. I focus on working with enterprises and software as a service companies on their API strategy and execution, as well as coaching individual teams on how to design effective APIs as part of the overall API surface area or API portfolio in their organization. My background is pretty varied. I've worked in a variety of different vertical industries, including commercial insurance, healthcare, hospitality, finance and banking, travel, and even helping to get a startup airline off the ground, literally. So I always like to start my talks off by reminding ourselves that API design is really an architectural concern. It applies architectural principles, and it combines the insights we have from business, product design, and software engineering. And without all three aspects involved in the process, we'll build APIs that really don't meet the needs of our stakeholders. So we know today's popular API styles for synchronous APIs include REST and GraphQL and gRPC, and we're also starting to see the emergence of a lot of asynchronous APIs. These asynchronous APIs help us to typically share events, but other kinds of messages as well. And they oftentimes answer questions like what happened, who did this happen to, and why did it occur? Much different than our request response APIs that we design today. It might include things like events when someone subscribes or unsubscribes from a newsletter. Or it could include commit records of when some particular person or a bot made a change to some code and issued a pull request. Whatever those events are, we want to take interest in them by subscribing to them and then reacting to them and taking action that wasn't previously designed into the system of record that emitted the event. In the past, we've had two primary options, API polling and now API eventing. Polling is where we spend time checking an API and making requests to see if the data has changed. So we constantly make requests to an API, see if the data has changed in some significant way, and if so, then infer the event that occurred. Long polling is a secondary version of that where we stay connected to a server for a longer period of time, hopefully allowing the server to send us some sort of update or allowing us to constantly check but not having to make new connections. Now we're seeing things where server push is more heavily involved than in the past. Instead of asking for new data or checking to see if there's new updates, we get notified whenever those updates occur. This may sound familiar. Those of you that have been working in event-driven architectures or using message brokers in the past are probably familiar with this. And we have two key concepts that we bring from that world into our async APIs. The first are queues. Those are point-to-point messages where we send a message from one particular component to the broker, say message A, and it goes to a component on the other side of the broker, someone that component on the left doesn't know about. It just knows that it sent the message, and it lets the broker figure out where that message needs to go. We send a second message from the component on the left to the message broker, and the message broker decides what component it should go to. Perhaps a different component subscribed to the same thing. Compare that to topics or the fan out or pub sub pattern, where when we send a message, message A from the publisher, it gets sent to the broker, and the broker sends it to every subscriber that's interested, so everyone gets a copy of it. So we have one where we can distribute messages and work on a single queue and typically have once and only once delivery whenever possible, depending on the configuration and design of the message broker, to one that allows us to broadcast an event to any number of subscribers. We've now seen the use of distributed logs as an alternative way to message brokers to be able to broadcast events or messages or data state changes. In this case, we have distributed logs that live within a topic. We have message records that are appended but never modified. And then we have consumers that can walk either from the very beginning of the first record that we have or the latest record that's published and react to that. Slightly different approach to that's offered by Apache Kafka and Apache Pulsar. And now we're seeing some combinations, particularly in Apache Pulsar, where the idea of queues and topics and distributed logs are being merged together and giving you the flexibility you need to handle the events the way you need them. All that said, we now have an emergence of HTTP and non-HTTP styles of eventing that are starting to crop up, and this is creating this category of async API styles that are complementary to our existing synchronous REST-based, GraphQL-based, and gRPC-based API styles that we've been using today. One of the most popular and one of the ones that have been around the longest is webhooks. Webhooks allow us to make a server-to-server communication possible, where a server that has, let's say, an API that makes changes to data can now broadcast an HTTP post request back to any number of subscribers that are interested in being notified. What that means is the subscriber needs to be a server into itself. It needs to be able to stand up a post-based URL and receive notifications on that endpoint. Therefore, we don't use this for things like web browsers. One really good example is using things like Cisco Teams and their WebEx Teams and their webhooks, as well as Slack-based real-time notifications via their webhooks. And we can even combine them, not just in unidirectional from the server where the data changed to the subscriber, but we can also have bidirectional communication. So let's say if we're doing a workflow, we might have someone who's asking for a review within a messaging app. That messaging app then broadcasts that message to a webhook dispatcher that then makes an HTTP post call to some other subscriber elsewhere outside of its own data center. That webhook receiver receives that message via the HTTP post, can pass that message on to a workflow engine, can then surface that to some sort of user interface to allow someone to approve a particular request. That approval's been noted in the workflow engine, then dispatches via a separate webhook to any interested subscribers that want to know when the particular request has been approved or declined and the state has changed. We broadcast that back to another receiver and perhaps then integrate that back into either the originating system or some other third system as part of the equation. So we can use webhooks to communicate back and forth between systems using post requests whenever some data change has occurred or some sort of significant event has been raised. We've also seen a few instances where server-sent events help us to bridge these kinds of events into the browser. The server-sent events allow a browser or any kind of API client to connect to a specific endpoint via a GET request. They mention that they want the content type of an event stream. We use a keep alive connection in HTTP 1.1. We don't cache the requests, and we can even pass in an optional last event ID that we've seen to recover when we've been offline for a while. We then start having the server push events, whether they're JSON, plain text, or some other event data, to an event channel, and that allows the client then to filter out and process events that it's received that it may be interested in. Just bear in mind that server sent events are only from server to client. So once the client makes the connection to the server and engages in an SSE session, it's only going to receive events from the server back. It will never be able to talk back to the server again unless it makes a separate connection. But it's really useful if we just need simple server push. WebSockets are very similar, but they're bidirectional. They allow us to tunnel through HTTP any kind of sub-protocol that we design. That sub-protocol then could be plain text, it could be SOAP-based API calls, or any sort of other type of sub-protocol that we decide we need. That WebSockets allow for bidirectional communication, so the client can send data as well as the server, and it allows them to have bidirectional communication throughout the session. So really, really powerful and useful, but we have a little bit more complexity because we have sub-protocols in place. GraphQL has the idea of subscriptions, where we can define a subscription of something we're interested in, and any kind of event that occurs based on that subscription detail will cause messages to be streamed back to us over HTTP, allowing mobile and web clients as well as servers to be notified when new data exists or data has been changed or any other kind of event has been surfaced. gRPC has bidirectional streaming support. It allows us to define a service operation that either accepts an incoming stream or emits an outgoing stream, or both, and that allows us to use over HTTP2 bidirectional communication underneath the covers, communicating between client and server. Really, really popular for microservices that are built with gRPC and need to be able to communicate back and forth. With that said, in all those protocols, we do have to spend some time designing our API. So I want to dive into design patterns now that we've had kind of a quick look at the different protocols that are out there and the ways that we can embed messages over HTTP. I love this quote from Tim Bray from 2019 in November. If you're going to start emitting events from a piece of software, put just as much care into the event design as you would specifying an API, because event formats are a contract too. And it's important to understand that. I see a lot of organizations designing events ad hoc, and the only definition of that event exists inside their code. If someone else wants to subscribe to that event, they have to crack open some code and figure it out. That works fine if we're all available within the same organization and we all have the same kind of access, at least read-only, to the code base so we can review it. But if we're outside the organization, that's not much use at all. So we need to really start thinking about the contracts that we design in our events and make sure that we don't break those downstream event consumers that may be depending on some events that we designed really quickly on a Friday afternoon to get some piece of software working. As we know, the AsyncAPI allows us to capture and discover these types of events and is a really great way of doing this. Within our AsyncAPI, we're going to be defining our message formats, and those message formats are the ones that we're really going to be capturing and applying these design patterns to. The first design pattern that I want to talk about is thin event notification. This is where we really only broadcast the necessary details about when an event occurred. This oftentimes forces subscribers to go reach out to some sort of request response API to fetch additional details to be able to complete the necessary logic in reacting to the event. We want to use this kind of event when we want subscribers to make sure they have the most current data. If we send all of the data at once on this event, but the data could have been changed by multiple API consumers making changes to the data, web apps, mobile apps, and so on, and we don't want that event processing to operate on stale data, the best way to do that is to send just enough information for that consumer to determine if they're interested in the event, if they want to act on it, and then have them subsequently make API calls to fetch the latest version of that data for processing. Building upon that, design pattern number 2 encourages the use of hypermedia-driven events. Just like our REST APIs that allow us to process or include links for clients to be able to make subsequent processes or requests for related data, or to conduct workflow-driven development and processing of our API or interaction with our API, hypermedia links and event payloads can help those that are using thin events to know exactly where to go to get that data. This is really, really popular when we have dynamic backend data sources. Perhaps the event may have come from a system of record, one of several, and we don't know which one we should be talking to go fetch that data. In the case of a hypermedia-driven thin event, we can embed the links to know how to tell the client or the event subscriber how to go fetch that data, and then subsequently how to process it. So this lets us bridge our request response synchronous APIs with the world of async APIs and connect them together. So it's very, very easy to subscribe to an event and then know where to get the data from. Really powerful. The third design pattern is event carried state transfer. Event carried state transfer is really the opposite of a thin event. It's when we broadcast all of the known data at the time of the event, allowing the consumer never have to go reach into that source system and fetch the additional data that they may need to conduct their work. Every bit of data that they may need, an entire snapshot of the data that's been changed or the event that has occurred, is included in the event payload. This is really important when subscribers want a snapshot so they don't have to call back to the API. It reduces load on the synchronous APIs. It also allows us to share data state changes and then aggregate those changes over time, very similar to event sourcing and CQRS style of patterns. It's very common in message streaming solutions like Apache Kafka and Pulsar, where we want to capture all the data at the time of the event, keep that as a snapshot, so that even if the data changes in the system of record, we have a snapshot of the exact state of the data at that point in time of the event. Design pattern number 4 includes structured event payloads. When we're designing our event payloads, it's oftentimes a preference to create more of a flat event structure where all the fields are at the top level. But when we start to add new events or new data structures, or we have names that collide, we could have some problems with the event payloads, and it makes the event payloads harder to understand, harder to consume, harder to write that subscriber integration code. So in that case, we want to have properties that are grouped together based on nested structures rather than flat structures. It allows us to group things like address structures and contact or profile details and other things together, and it allows us to use the same field names and apply some level of context to them. So looking at this example on the right, imagine that we were managing a contact profile with 2 billing addresses. If we had them all flattened, we might have contact first name, contact last name, contact email, billing address line 1, billing address line 2. It makes it a lot more difficult to reuse structures on the consumer side and to be able to parse that payload and apply validation rules if they're all flat and we have to repeat the code that's used to enumerate through billing address, address line 1, and billing address, address line 2 versus the mailing address line 1 and line 2. So grouping them in this way allows us to create these structs. We might create a struct on the consumer side called address. We parse out the payload. We assign the billing information to one instance of the address struct and mailing to another, and then we can perform validation or any kind of logic that we need. So if we have complex data structures, consider nesting structures into related data. It allows us to have one-to-many nested children inside of our event payload structures to represent the relationships that exist on the back end that we want to convey to our consumers. And it also allows us to evolve our payloads over time because we can add new top-level property names with nested structures that will offer the contextual semantics for the subscriber to make sure they understand how to process that payload efficiently and effectively. The 5th design pattern is evolutionary event schema. So we want to keep in mind when we design our event schemas that we apply some non-breaking changes. This goes back to Tim Bray's quote about making sure that we design our event APIs to withstand evolutionary design changes and making sure that we communicate that with everyone that's using consuming the API at the time, or consuming events at the time. So in this case, we want to make sure that we only add new properties that have default values or that are not required. So that if we're going back and processing aggregated events, that we have some default values that can be applied retroactively. We don't delete existing processes, or we don't delete existing properties, unless they offer a default value. So if those properties are missing in the future, we can rely on a default value for that consumer to be able to use for that field value, and that we don't rename property names. A lot of these things are documented well when it comes to Avro schema definitions for Apache Kafka, and those things should be heeded carefully. We have to keep in mind that some of our events, particularly those that are stored in a distributed log and may be revisited back to time zero, where we didn't have certain fields, they're going to need those values to be able to aggregate, or default values that they can depend on. So it's almost similar to the way that we design non-breaking changes in request response APIs. The difference is these events may be laying around for a long period of time. They may represent an event that happened a day ago, an hour ago, a minute ago, or it could even be weeks or months ago or years ago, depending on how long our retention period is for our events. So we need to think about what would a consumer today do with an event previously emitted, let's say weeks ago, before we added a new property. Is there a default value that can be applied? How do we do that? Each consumer needs to know how to do that. We can't just put that in the documentation. We need to think about what that means to the schema and what that means to any consumers moving forward. So when you think about event payload changes, apply some evolutionary event schema patterns. Make sure that you avoid breaking changes and that you make it easy for people to go back to historical events as well as deal with future events when the schema has changed. Design pattern number 6 includes the support for offline and error recovery support. So when we think about our consumers, it's very easy to think about the happy path, the fact that our consumers or our subscribers are receiving events from our async APIs all the time. But what it doesn't do is think about people that go offline. What happens if the code's been updated and there's a bug in it, or a data center goes offline for a period of time and we have some events stacking up that haven't been processed? How do we come back and reconnect with our async APIs and recover from where we left off? Server sent events are great for that because we can specify the last event message we've seen, and the server could then start sending messages that you've missed. This may include also durability on the server side, keeping track of events that have been sent to a particular subscriber that's offline so that when they come back online, we can push those down and let them get caught up. It may also include APIs that let us catch up separately. Maybe a GET API that we pass it the message ID that we last saw, and it can send us everything that it knows before we start receiving the latest event messages. In the case of this example here, GitHub is offering a web API that allows us to see every webhook and whether it's successfully delivered or not, and allows us to help us troubleshoot as well if our systems go offline without realizing it or are stumbling over the processing of an event and throwing errors, and GitHub is catching those errors and logging them. So make sure you keep in mind consumers that have limited or no access to internal mechanisms, how you're going to automate these processes just so that not only do you have a web interface to allow you to see delivery failures, but there's an automated way for a system when it restarts to recover. Make sure you build that in either through synchronous request response APIs using our REST patterns that we already have in place, or using protocol level recovery options. Design pattern number 7, we need to separate our internal and external events, and this is really, really important. When I see teams designing different kinds of events, I see them oftentimes taking their internal events and directly pushing them over webhooks or SSE. And while that might be useful for an internal service-to-service communication to see those internal events, we don't want to expose a lot of internal details to our external consumers. They should not know the internal details of how we built things, nor should they be dependent upon our internal messaging structures that we use to coordinate our internal services. Services change, they split, they merge, they go away, and sometimes that might have an impact on our external event consumers if we share the same kind of event. So we want to make sure that our internal events for coordinating implementation details are separate from our external events that we want to use to notify or allow other systems to extend what we do when we have events that occur. So think about a payment processing solution where when we talk to our payment processor, we may get some information back like you see on the top here, the transaction ID, the authorization server, merchant IDs, all kinds of additional details about how we integrate it in with a payment processing gateway. that information may not be very useful to someone who just wants to know if an order's payment was processed or not. They don't need to know what the merchant ID is. They don't need to know necessarily what authorization server this request was routed to on the back end of your payment gateway. Instead, they just need to know that it was processed successfully. So differentiate your internal events from your external events, and also consider how much data you're leaking if you leak internal events out to your external consumers. Details internally could be used maliciously by people that might get a hold of that event data at some point. All of that to say that when we design our API, asynchronous API event structures, we need to think about the jobs to be done. What is it that people are doing? We have a lot of messaging platforms today that allow us to interact between one another and chat with one another, and now we're starting to see workflows emerge inside of there. So those workflows allow these bots to be able to query APIs and use hypermedia links to determine what options are available and surface those to the end user for direct interaction with a human. Once that's done, it generates an event that tells us what happened or what that person decided to do as a result of that bot bringing to their attention some sort of decision that needed to be made. So when we think about that, we don't want to think about all the internal decisions and service structures that we have. We want to think about instead the type of events that occur as a result of those interaction points. All this leads us to the evolving enterprise platform. We have APIs today that deliver capabilities through commands and queries, our gets, our posts, our puts, our deletes. And we have events and streaming that are now offering extensibility of our API platform with our various async API protocols that we talked about earlier. We can then combine that with the OpenAPI spec and the async API specs to make discovery of request response, synchronous APIs, as well as asynchronous events and streams available to us. This is really driving a lot of the innovation that's occurring within enterprises and SaaS companies today between their customers and their internal workforce and their internal systems. We have APIs that may be decomposed into services, and those services emit events and streams, and those events and streams can then be subscribed to either remotely over HTTP or internally via functions as a service, stream processing code, other services that react to those events. So we're seeing this really robust API platform that's starting to emerge, and it's really, really exciting to see all this happening. And async APIs are going to be just yet another way to extend the reach of our API platforms and products that we offer today. That's all for me. If we have any remaining questions, I'll be around to be able to answer them. Thank you very much for your time.
Okay. So thanks, James, for this amazing talk. We were just chatting for those of you who weren't here. We were just chatting, James and I, the cool welcome that is having on the warm welcome actually that is having on the on the YouTube chat, and the interest it's generating, right? He was just saying like he didn't know if it was going to work or not, right?
Yeah.
Right.
Yeah. That was the first go for some of that content, although I've had it sitting in the background for a while, kind of waiting to be used. So I'm glad that it's been useful for a lot of people.
I agree, and I agree with you that whenever you go to a conference, it's super hard to know if this is gonna create some interest or not. It's like,
yeah,
is it just my stuff? Am I the only human worried about these things?
Exactly. Yeah.
Yeah. So I can completely relate to that. So yeah, I think we might have some time for questions. You did a great job with timing, so we really appreciate. And if not, I mean, if someone wants to jump in with a question, or if there's a question you want to reinforce the answer with something else, feel free to jump in.
Yeah. Since we're waiting for a question, I can just briefly share. As I mentioned earlier in the intro, I work with a lot of different organizations, and many of them have been doing event-driven architecture for a while, but their event schemas are stuck inside of code, or they haven't really treated their event definitions at the same level as they've treated their REST API definitions or previous to that SOAP and other types of styles. So one of the questions that came up was, how do I get started? And I think part of it is recognizing that it belongs alongside the API design process. So incorporating that in early and helping to identify and surface those events will help. And then people start asking, well, how do we do the same thing with this that we've done with REST? And then you can jump in and show, well, look at this magic website and specification and set of tools that we have that can help jumpstart the process. So I think that's key, but recognizing its importance is first and foremost for any organization.
That's true. That's very true. So since we don't have any question on the chat yet, and we still have like 1 more minute, I would like to ask you or something, one point of your talk that I really loved, because it's been on the top of my head for some time. And it's, hypermedia events. I think Joyce said something like Joe drop. So how exactly are you imagining this, like this happening? Because I wanted to explore this a while ago, but too many things you think about, but you never do.
Right. Yeah, I think it helps really with thin events. If you're storing data into a stream, let's say Apache Kafka or Pulsar or something where you have a distributed log, then those hypermedia links may not be as useful because over time APIs may come and go within an organization. Ideally, you have a plan to sunset them, but if you're going back to T0 and there was a link to an API that didn't exist, maybe not as ideal. But for events that are surfacing notifications, they're probably thin events, and you want to encourage the consumer to go fetch the latest data, then just simply embedding them using a how-like or other type of specification, hypermedia format specification structure into the overall message structure will help point consumers to the right direction to fetch the latest data. Loosely binds the event stream to the APIs where you go fetch the full set of data, and basically creates the glue or the full circle around from perhaps a command coming in via a REST API that triggers a state change, that triggers an event notification, that then causes a consumer to come back to that API and fetch the latest state so that you can act upon it appropriately and not have to know what source what's the master source of the data. How do I go fetch it? It's all right there for you. It could also tell you whether actions would take place. So I think it's giving us an opportunity for workflows and things like Slack and Teams and other solutions where you might actually embed the options that are available now as a result of that state change. Should I be approving it, declining it? Can I reject? What are the things that I can do? And those links afford that as well, so you can surface it to a human to interact with in some sort of communication or messaging platform. So it starts to open up our world quite a bit when we do that.
Makes sense. It can actually act as a glue between events and REST APIs, if you think about it. Yeah, it's awesome. That's an interesting idea. Well, thanks, James. We'll have to let you go. Thanks for joining today. And I think next step is Emmelyn. So we'll go for a break now as usual, and we'll come back in a few minutes.
Great. Bye, everybody.
Bye.
Okay, we're back after the break. Hello again. So next speaker will be Emmelyn, who will talk about simple ways to get your organization to adopt AsyncAPI. But I would also like to use the opportunity to shout out and thank you, Emmelyn, for not only presenting today, but also your all effort on making us visible in a Women Who Code initiative, helping me with the contact with the group. So thanks a lot for your help to the community. And yeah, let's start the recording.
Emmelyn here, live from Dallas, Texas. Thank you so much for joining AsyncAPI's very first online conference. How do you get your organization, your product leaders, your government to adopt the AsyncAPI specification? Quick frame of reference. The API specification should be at the core of all activities. Everything around that will then be systems that balance and integrate a variety of considerations, especially for business stakeholders. And finally, what do people experience? So the toughest part actually about adoption is not the technology itself, it's really your company culture. So I was just gonna show you some ways to really build that alignment that should be focused around the spec and what you can do with that. I'm gonna show you examples of how to get AsyncAPI visibility and in context with what your company's doing. How do you show AsyncAPI love and bridge the gap between, hey, this seems like something just deeply technical, why should it matter to me too? Oh wow, I'm incredibly excited with all of the millions of sensors that I can connect and manage, for example. Also, I'll briefly touch on how adopting the spec as the input, that's actually the glue which determines long-term health of your API products and platform and connects it to the rest of the API ecosystem. I found out about AsyncAPI because I wanted to be part of an open source community. So I met Fran, the founder of the spec, and the community is very welcoming. I immediately got involved, not because I'm an expert at event-driven architecture, but because as an API strategist, I wanted to learn more. I was lucky enough to meet Fran in person in Spain, and our product kickoff was in Barcelona. I introduced him to all of our C-level and executive leaders, as well as my colleagues in the greater API community, and vice versa. We sat in the lobby, and what we did was Fran showed me how to work and contribute to the spec, as well as what was in flight for the community and the spec itself. We're super lucky. Alan Dennis and Eric Kresny, CTO and CEO respectively of Stream Data, they were acquired by Axway and had already been working with Ken Lane to contribute to this effort. And so there was already that connection, but I continue to bridge that relationship, and you'll see it reflected in the rest of this talk. So it's really important to weave the AsyncAPI spec into business contexts. Tell incredibly interesting stories like the ones we're hearing today. How are you using the spec and focus on the results of the adoption of the spec? You have to tie in the incredible possibilities with the actual how. That's where you're going to need to get your hands dirty. Using AsyncAPI spec is a standard that helps you move a lot faster. Because it's a sister spec to the OpenAPI spec and the communities actually overlap, you're able to build on a shorter learning curve. So I'll give you an example where a gentleman who was incredibly smart and he was able to turn surveillance on his head in real time. When you have a standard in place that allows you to connect parts of your product to your platform and to your greater ecosystem, such as onboarding a supplier or a vendor faster. A sister spec also helps decrease the learning curve. AsyncAPI spec, since it's a sister spec to the OAS spec, OpenAPI, it helps you to do more faster. And the reason why that's important to the health of your API platform is it's a very competitive landscape out there. So when you go to this website featured in the book Burst that talks about human pattern and behavior, you'll see that this gentleman, he's been diligently tracking places that he goes, the food that he eats. And it's just a very interesting data set, especially as it relates to network medicine and helps us to understand patterns of human behavior. Mr. Eric Kresny here, he, as an executive working with major financial institutions and highly able to articulate how artificial intelligence and different API models relate to the adoption of AsyncAPI. He focuses on the developer community, engineers and architects who are consuming the spec. And so it's really important to stream that data in real time, generate excitement. Governments can now proactively protect its citizens. Companies can do the same, which are the human aspects of event-driven architecture.
Hello, Mr. Yakamoto. Welcome back to the Gap. How does assorted tank tops work out for you?
Minority Report was pretty scary. Remember the scenes of him having to get some eyeball implants. So that's not how we get people excited about the spec. But we can get people excited when it comes to managing, for example, sensors at scale and using machine learning to better manage the asynchronous networks that we build. Another way is to get people excited inside the company. I started gathering all the information and drumming up excitement on our intranet. And at the time, people were just kind of like, I don't really understand what you're talking about. It's just event-driven architecture. Why is that important? I wrote this article in March of 2019. It has 229 views, and you can see that it's got a pretty positive sentiment. We were able to adopt the AsyncAPI in one agile sprint using playground.asyncapi.io. I also wrote an article and worked with experts, both inside my company as well as with our good friends at Solace, and worked with Fran and then with Eric. And as you can see, we basically had like an AMA, posed some questions and had each one of them answer the questions. The reference point was what the community is most familiar with, which is REST APIs, as well as people sharing the article. And so I just want to thank this community for doing so and keeping people curious so that we attract the best talent to the spec. It's also really important just to try things out. So I'm seeing in our Slack community channel, people asking questions, and I'm incredibly appreciative of the maintainers for addressing them in a quick way. The AsyncAPI editor is another way that, it reminds us of the OpenAPI specification, but now you can use MQTT, Kafka, other protocols, and that means that you get quite a bit of interoperability among those different formats. Again, I mentioned the AsyncAPI Playground. This is fantastic because you can try out different use cases and share them with the community if you can. So in doing all of this, leading by example, some people might be skeptical, but some people might mirror your behavior. So Alan Dennis, in response to all of this contribution that we've made together, he wrote one of many intranet posts. And as you can see, he just published it in January, had 135 views. And then he's written several articles as well and created videos. So I hope that gives you a few ideas of how you can get your company to gain interest in and adopt a specification and kind of tie it back up to that greater API ecosystem. Thank you so much, and I'll see you in the questions or on Twitter or your favorite platform.
Okay, we're back live again, this time with Emmelyn live. Thank you a lot, Emmelyn, for your lightning talk. And we have less than a minute, but yeah, would you like to add something to your presentation to comment it?
Absolutely. Thank you everyone for making it a fantastic community to be part of. This is a great place to learn, and I'm just incredibly grateful to everyone globally for the warm welcome and participation. Has anyone tried any of the methods that I discussed in the talk when talking to your leadership or other people in your organization? This is kind of one of the toughest pieces, I think. Awesome, Manish. Yeah, feel free to connect with Alan, Denise, Eric, Koresny, or myself at any time. We would love to help your organization or government entity adopt the AsyncAPI spec in one agile sprint like we did.
Okay, thanks a lot, Emmelyn. We're gonna make a short break now to make a quick round of the slides to thank our sponsors, and then we're gonna have another talk from the, yeah, you know who, Mr. Fran. But yeah, now a break. Thanks a lot.
Thanks.
Hey, after the break, now almost the last talk. We will have now Fran and then Matt. But yeah, enjoy this next presentation from Fran. This guy somewhere here on the recording. You're gonna really enjoy it, I'm pretty sure, and you're gonna learn about the past of this pack, the present and the future, which is for sure amazing. So yeah, enjoy.
Thanks.
Hi, folks. So my name is Fran Mendez. I'm the founder and the creator of AsyncAPI. Thanks above everything today. I think it's a special day, so thanks for joining the AsyncAPI conference. It's been wild the last 3 weeks. It's been impressive. We just got crazy and said, like, we have to organize this and make it happen. So here we are, and thanks for joining us. Today, I would like to introduce a little bit to those who are not very aware of the past of AsyncAPI, where it's coming from, right? Like, not just what we're doing or what we're gonna do, but understanding the past is also nice, right? So yes, as I said, so my name is Fran Mendez. You can follow me on Twitter and or just send me an email if you have any request. That's my beautiful me when I was still beautiful and had some hair, not crying. And yeah, so let me go a little bit back in time and explain where AsyncAPI is coming from, right? So a few years ago, I think it was 2017, I was working at a company with a friend of mine, Bruno Pedro. We were working at a company called Hitch, or it's also known as API changelog. You know, that was the name of the company and the feature. So we were an API changelog, so it was cool. That evolved over time into a full API documentation and API support product, and that was actually super cool to build that. But to the point today is that, as you can imagine, building a changelog itself, a changelog is a system, an evented system, right? So it consists of different events, like an endpoint has been created or something has been changed. So it's always talking about events. So our architecture as well was consisting on event-driven architecture. At the time, we were using RabbitMQ, and if you go back to version 1 of AsyncAPI, you will notice that there was a strong bias towards AMQP 091. the protocol powering RabbitMQ, and yeah, it was like it was enough for us, right, to do the job for us. So yeah, the cool thing about working at Hitch and with a friend of mine and working on this architecture was that, and architecture and the kind of product was that we were building a product on top of OpenAPI, right? For those who don't know Swagger, the Swagger specification or OpenAPI specification. And we were, call it like that if you want, we were kind of experts on OpenAPI and Swagger. So we were very used to automate lots of things like creating documentation, generating code, bootstrapping code for your services or APIs. So we were very used to that tooling, right, and to that ecosystem. And suddenly we got the duty of creating an event-driven architecture, and there was nothing similar. It was like, I can't believe. I think the third time I was copying and pasting the code from one place to another and modifying a few things and uploading the documentation as a README on a GitHub repo and trying to have the documentation reflect what actually was doing the code. The moment I faced that, it was like, we should be automating this like we're doing with OpenAPI, right? And with REST APIs. So yeah, we started drafting this crazy idea of let's use OpenAPI and adapt it to our needs. Like get means subscribe and post means publish. The request body is the event payload, and we don't use responses because we don't need it. So it's like, yes, it kind of does the trick with documentation, but not so much with code. Whenever you had to generate code, it's like, you have to start over again. Like you have to change all these code generators, and instead of generating a REST API, they have to generate I don't know, AMQP service, right, connecting to a broker. So like this conference today, like the decision of this conference today, I just got break one day and get crazy and say like, let's just fork OpenAPI and start reading it from top to bottom and change everything. It took me a while, but two cool things here is, one, I was able to understand much better the OpenAPI spec, which has a lot of things people don't know and really cool things. I still recommend people go to OpenAPI and have a look at it. And the second thing is that I managed to abstract the design of the spec, or at least I tried, the design of the spec to suit not just my AMQP services, but also some MQTT services, and try to do something that could be useful for everyone, right? And like I said, even though it was obvious that there was a strong bias towards MQP, at least I tried there. So that was a fun work, and I just published it, and we decided to go at Hitch and promote it, right? So at Hitch we had something called API chats, and here you can see me, a younger version of myself, together with my friend Bruno Pedro, who actually inspired a lot of the things, including the name AsyncAPI. So yeah, we presented this API chat one day. I actually don't remember the date, but it was like around 3 years ago, and introduced AsyncAPI. So that's pretty much like where is it coming from. I hope you enjoyed the let's say the origins of AsyncAPI. There's a lot of more story behind it. Like I just tried to summarize a lot, and but I think it's always cool to get back and remember the funny stories, the old stories, right? It's only just 3 years ago, but it seems like a life has happened in the middle, right? So I would like to go from past to present and then go to future and explain what are the plans for the AsyncAPI initiative, not just the spec. And so today I would like to say that regarding the spec nowadays, I would like to remark that recently we launched version 2 of the spec. Some of you may already know about it, especially the great community that we built around AsyncAPI. For sure you know about it, but I'm assuming that there are lots of new people. So we launched the version 2 and started building a lot of tooling. And when I say a lot of tooling, it's a lot of tooling. And we started building code generators, documentation generators, JavaScript parser, AsyncAPI converters, so converters from version 1 to version 2, so you don't have to migrate them manually. Lots of stuff, even a playground that you can play with, right? And the cool thing is that this tooling is maturing slowly, but it's maturing, right? And right now we're pushing a lot of effort into making the JavaScript parser and the generator reach version 1, so the stable version, right? And so we can build a better future on top of that. Also, I will not like to forget that right now it's not just myself. Right now we're 3 people together. I'm here together with Jonathan, sorry, with Lucas Gornitsky and with Eva. Eva is also happens to be my wife. So we're a nice team of 3, and I'm sure we're gonna rock on. And also a big shout out for the people, for the community, the vibrant community, the growing community that we are building around the project. It's amazing to see the support that we're having lately. Especially, it's growing like hell. So it's unmanageable sometimes, but we're very glad of it, right? And yeah, so that's pretty much where we are now. We are on version 2 of the spec, and we are building tooling to support version 2 of the spec, and trying to make it stable, the tooling, I mean, and so we can build a better future. So back to the future, right? So going a little bit into the future, on the plans that we drafted for this year, and I would like to remark that these are plans, so we're always trying to adapt to the community needs. But I think we gather enough information during the last year to understand what are the priorities here. So we would like to share a summary with you. And yeah, by the way, after or even during the talk, because that's the cool thing that this talk is pre-recorded. Let me share the link to the roadmap. Where we have everything described. What's the roadmap for 2020, right? That's a summary. Let me summarize this. I want to start with the biggest, for me at least, in my opinion, this is the biggest change in the whole initiative. So those who have been around for some time know that this has been my side project for some time. It's been growing until it got out of hands. And I'm trying to make this as less Fran-centric as possible. So this year, we're committed to at least try, if they want, of course, join a new neutral home. So what does it mean? We're going to explore joining CNCF or OpenAPI Initiative or Linux Foundation or other kind of foundations. So the project is not my stuff, my personal stuff anymore, right? It is not anymore, but at least legally speaking, it's not my stuff anymore, right? So we can build a healthier community around them, and not only about people, but companies around them, and make it grow. So that point is actually part of a bigger goal that's what we call it, of trying to make AsyncAPI the standard specification for event-driven architectures. We want to become the standard for that. Not the only standard, of course. There are other cool standards like CloudEvents, for instance, who are doing a great job. But I think we can work together and offer a better or a bigger solution in terms of scope, right? I have my 2 cats here around, so maybe you hear them. So yeah, was saying that that's the one of the biggest goals. Let me jump into the next one. So tooling is always a priority for us, especially lately that we have stable or a version of the spec that we're happy with, which is the version 2. And tooling, again, needs to be mature. So we're now building a lot of code generators and a lot of documentation generators. For sure, this is something that needs to improve, and over time as well, right? So what we want to do here is make JavaScript parser and generator stable, so people can build on top of that. So that's a top priority for us as well. Also, during this year, we want to release version 2.1 of the spec. We might release also the 2.0.1, so a fix or a patch version, fixing some things here and there, just which changes nothing. It's just the text, like typos and all this stuff. But at least by the end of the year, we will be releasing the new version of the spec, which still we don't know what's gonna contain exactly. We have some candidates, and we will be deciding together with the community what's gonna be included there. So IDE support, we all work on the programmers. We all work on our favorite code editor, and we would like to work or not abandon our editor to work with AsyncAPI, right? And to have features like auto-completion and linting, for instance, like the tool that the folks at Stoplight are building. So they're building don't know how they call it, but it's spectral. Is a spectral plugin for AsyncAPI, and it's pretty cool because it lets you lint your AsyncAPI file, and instead of getting errors like syntactical errors, you'll get recommendations of things that will be better to do it in another way, even though they are valid. I'm terrible explaining the spectral tooling. Sorry, guys. So yeah. Building better IDE support, like Visual Studio Code extensions or IntelliJ IDEA plugins, so you don't have to abandon your IDE and start building a better ecosystem there. That's so documentation has always been my passion as well. I assume, I recognize that I didn't have enough time, or I didn't put enough love on the current documentation, even though it's not that bad. But we need to do better. If we want people to adopt AsyncAPI, we need to be building tutorials, better guides, online courses, webinars, with like all kind of documentation. Even the reference itself needs to be better. Examples, like lots of examples. We're gonna be targeting this year, and if we are and if we manage to do it well, like we're thinking, like it's on our heads, this must be a really nice experience and a really pleasant experience to start getting started with AsyncAPI and getting up to speed and until you have something. So this is also one of our priorities for this year. And last but not least is team tooling. What do I mean by team tooling? So far we've been seeing all the generator, the documentation generator, code generator. That's cool for solo developers. Like you can do stuff and maybe you share it via other mediums, but it's only for you. So we would like to create something that's for the teams, to work with AsyncAPI, because in the end, event-driven architectures are distributed architectures, and most probably it's a distributed team who's managing that. So yeah, not entertaining you more. Let me jump to the next slide, which I think it's to me is the biggest thing of the talk today. Let me introduce AsyncAPI Hub. So AsyncAPI Hub is like an evolution of our current playground, and we've been using the playground ourselves, and the playground has its limitations. Like for instance, we wanted to save our own files in the playground, and it was like not really. It's not possible, because then you will have to manage permissions, accounts, team settings, all this stuff. We did it. So we did it. Just to make it clear, as always, and following our passion for open source, AsyncAPI Hub is going to be open source as well. It's not yet public. We're going to open source it probably around next month, or next week, or in 2 weeks. So yeah, stay tuned. And let me start with a little bit of a demo. Let me change the screen that I'm sharing. Okay. Cool. So here's an example of the current hub, AsyncAPI Hub. You can find it on hub.asyncapi.io, so following the signature that we're using for the playground. And as you can see here, it looks pretty much like the playground, but it has enhanced capabilities. Like for instance, instant validation here. So whenever you use something that you don't, or you mistype something, or you do something that is not AsyncAPI valid, it tells you the error right into the editor. This editor is the one that's powering Visual Studio Code, so it's pretty cool. And you can see here that it tells you the error, so you can fix it, right? You fix it back. Cool. So one of the things that also allows you to do this one is we have a button here that says save. Where is it going, right? Where is this save going? So let me first show you this tab here, directory. So we have the concept here of organization, project, and AsyncAPI files, right? So the thing here is that I didn't create anything in advance, so you can see the whole process. I'm going to create a new project, and my organization is called Smarty Lighting. For those who have seen my example with street lights, this is the name of the fictional or the fake company. So let me create the name of the project, Streetlights. Create, and it says there's no async APIs to show yet. We're filtering by streetlights here, and there's nothing. So let's create one. Let's create an async API on the Streetlights project, and I'm gonna call this Streetlights API. Okay. So we create a Streetlights API, and it goes straight back to the editor. But this time you can see the path here, the breadcrumb. With the Streetlight API open. I have something here to share as well, which is the content of the Streetlight API. As you can see, this API here, this async API file here is not the example Streetlight, the Streetlight example. So let me import one file from our examples on the repo, on the GitHub repo. And ta-da, we got the async API, the Streetlights API. Let me save it. So cool, sets down. Cool thing you can do as with the playground, you can always download these HTML docs on the right side, or you can download this Markdown. We will add more stuff here, like code generators and all the stuff. And the cool thing here is that you can see now in your directory that you have a Streetlight API. So that means that you can use this platform, this product, to store your async API files that you play with, and you can, if you come here, you will see that your organization has members. And in my case, I invited Eva to join my organization. So Eva will also, if Eva joins the product that the async API have, she will be able to see my the Streetlight API that I just created. So we can collaborate. Both of us can collaborate on that, and also you can send invitations to other people. So that's pretty much the demo for the async API Hub today. I hope that you are as excited as I am for this new addition to the async API tooling. That's what I like to call it, right? And I think that's it. Let me spend some time now with you online, live, to answer some questions if I still have time, which I have not controlled how much time I have been talking. So thanks for attending, and I hope you enjoy the rest of the conference. I'll be online, and happy to chat. Thanks.
Okay, folks, I hope you enjoyed the talk. So Lucas, you wanted to say something?
I'm so amazed.
Yeah, sorry. It's just so the audience understand what happened here right now is we had no clue when my talk was going to end, and it was supposed that he was going to say like, hey, well, so we had Fran, blah blah blah. But it couldn't be. So yeah, sorry. Like I said before, I'm here to reply some questions that you might have. Yeah, so let me have a look at the chat. I hope that at least you are as excited as we are with AsyncAPI Hub. So just to clarify a little bit what AsyncAPI Hub is and what it's not, right? AsyncAPI Hub is another project from the AsyncAPI initiative, and it's going to be open source. The reason it's not yet open source is very simple and shaming on my side. It's just the code is not really ready. It was there's a lot of patching here and there while I was experimenting. So I didn't want to share it yet, but I'll be sharing in the next weeks. So yeah, we'll be open sourcing the project that will have its home on AsyncAPI. It will be free to use and open source, so you can install it in your servers if you want. And yeah, so you know, as the usual open source model. For sure, we will run a hosted version ourselves, like the one I just demoed. We'll keep it there for simplicity in case you want to use it and in the future share links with other people and share documents with other people. So yeah, that's pretty much what the AsyncAPI have is so far. Let me check if there are some questions. Looks like there's not. Thanks for all the compliments and all the great jobs and all the cool things. So yeah. I think we have some time. Let me check. So actually, no, we're right on time. So perfect. So next up is Matt Bishop. He'll be closing the conference today. And but before, we'll do a small break, right, to show our amazing sponsors. And yeah, we'll come back in a few minutes. Okay, getting back from this small break, we're about to watch the last talk of the day from Matt Bishop. He's based on Vancouver. Correct me if I'm mistaken, but Vancouver, I have something to say about it. I think this is one of the most beautiful cities that I visited in the last years while traveling. So happy that we have people from Vancouver joining, and yeah. I hope you're enjoying the conference so far, and no more distractions, so more talking. Matt Bishop.
My name is Matt Bishop. I work with the Adaptech. Adaptech is a CQRS event sourcing consultancy. It's founded by Adam Dmitruk, who has created the event modeling framework. He's been working with Greg Young, who's famous for the CQRS architecture, and Nicholas Dextrazi, who is the CTO of Adaptech. The three of these guys have been working together for 10, probably 15 years now to work on CQRS as a concept, and working with clients to build out systems that use CQRS and event sourcing. In the course of the progress of this work, Adam has built out a concept of design called event modeling. If you're familiar with event storming, you can think of this as taking it to the next step or the next level. Event modeling creates an information blueprint that can be used by teams to build out software systems using what you see looking like this, in more detail, of course, but for the most part, a single view of the information system and the components that need to be built out therefrom. It's a collaborative design process that involves everyone in the business. It's workshop based. So the workshops usually run between 3 and 5 days, depending on how much there is to discover and how much the company or the client wants to build. Involves an infinite whiteboard, stickies and pens, or digital whiteboard. We found that when a workshop starts with the physical, it invariably ends up going into a digital whiteboard, especially over time, to allow for communication across larger groups of people. Editing over time, it becomes that place you go to look for what is being done, what has changed, what's coming next. It's an open board, so everyone gets to add to it and edit it. And in the process of it, it feels fairly chaotic because there's a lot of people who don't normally make software or describe software working together to create the event model for their business. We try to bring in the people who own the business, who run the business, who operate in the business, who use the tools that the business uses to do their work. If there's any subject matter experts that need to come in, we'll try and bring them in, and of course the developers who are in charge with actually building the system that comes out of it. In the real world, it looks something like this. You got stickies on the wall. The organization of it, I'm going to walk you through, but it's very intentional, and it's part of the workshop is to go through several steps of process to come to an organization of the elements that you see here. There's 7 steps. I'll walk you through these steps now. These are not a waterfall set of steps. They generally group together, and then so follow the steps for a while, and then you go back and refine as you discover new things, or you make decisions, or you decide to make some changes. But the board itself, or the blueprint itself, goes through these stages before you come to the completion of it. Okay, the first one is called brainstorming. This is a step where you really try and draw out of the participants what it is a business does in terms of events. So you use this time to teach the participants what an event is, the concept of something that happened in the real world. It's something that's happened in the past. It's an unalterable, immutable state of fact. You can eat a taco. Taco eaten is an event. You can't uneat a taco, right? That's just something you can't change in the world. And so that's what events are. A lot of times you spend a little time as well talking about observations versus state change events. State changes are the ones we're interested in. Observations are things that occur, but they're not really relevant. So for instance, oftentimes you'll see people put up what they think of an event as customer entered store. That's an observation. It happened. You don't need to record that. That doesn't change the state of the system. So it's not really an event. But customer made a purchase, that is a state change that's interesting to the information system that we're modeling. After you've discovered the events, or a lot of the events, or a good set of them, then you move on to the next stage, which is creating the plot. The plot is where you introduce the arrow of time. And you explain that things happen in a sequence, and you are trying to find the sequence of events that lead to an end goal. So they discover the end goal, and then often you work backwards from there to line up the events as they occur, so that you can find what the plot is. You may find there's more than one plot, and that's fine. You make more than one, but you really try and get the events that have been discovered in a row or in an order that tells a story, because what you do next is you build out a storyboard. The storyboard connects these events to artifacts or applications or processes that the business uses to execute their work. So these aren't high fidelity mockups, they're wireframes. The processors are basically, steps where somebody makes a decision, or a system makes a change and makes a call out or does something along the way. But it tells the story of the events, but using props, if you will, or artifacts that they're actually going to encounter in their actual use of this application or this system. From the storyboard, you then work out the inputs. Now, this is an interesting step because up to this point, people who are coming to this believe that these user interfaces, these processors, generate the events directly. And this is where we talk about these commands and how a command is an intent to make an event, but it's not a guarantee. And there are handlers that listen for, that take these commands and check them against the state of the system and verify that it is okay, according to business rules, for this to occur. What you want to provide to the business or the information system is events that are trustable. You believe they are correct. You don't have to validate that they should have occurred. That's what commands are for. So commands can be rejected. It's a request to make an event, and they are in blue. So each one of these will be a handle or a piece of code that will look at the events that have occurred to determine the state of the system as it is now, look at business rules for the shape of the data coming in from the inputs, and use those to create the commands. So you'll notice that we have lines directly from the screens to the events. We use this to capture the fields, those information fields that we are showing and capturing data from in the user experience. We want to tie those into the commands and events so that we have traceability. You know where this data came from because you can follow it back to the input that it came from. Similarly, we talk about outputs. So when these events have occurred, what happens next? So the things in green are called views. A view is, sometimes they're called aggregations, or there might be a projection or a read model. These are output data frames, if you will, that are going to go to other systems. So in this case, you can see there are frames being used to render calendars, to-do lists. There are frames that are being sent to processors to do external operations. Those external operations then feed back down with commands to do whatever they need to do to describe. They can also be output syncs, like a report at the end, like a sales report. These views are computed solely from events, and they produce data. They do not actually generate SQL or HTML. There is another piece that listens for that and translates it out. So you're trying to keep this pure and data and very functional in what you're designing. After you got these done, then we do what we call apply Conway's Law. So Conway's Law, if you remember, states that the organization of a business is reflected in the architecture of the software that they produce. And what this means is the way that the teams are composed determines the architecture of the system. That's not something we find to be ideal. Teams are often composed by for reasons that are more political than relevant to the tasks that are at hand. And so also teams are often composed around silos of capabilities. So the team that handles one part of the system handles for all parts of that, and that doesn't actually line up very well with what needs to be done as far as the events and the timeline is concerned. So we use swim lanes to organize these by specialization. So along the top, the swim lanes are organized by the actors, the people and the systems who are actually going to be utilizing those outputs and generating the inputs. So for instance, like the very top one, you'll see there's like a checklist and a form for rooms and cleaning. These are different actors, and they have their own specialization. Along the bottom, you've got a registered row. You've got the payment requested row, payment succeeded row. This one is a specialization based on the type of information that's happening. So you can assign those to different teams, but you know which ones go together by these swim lanes. And then the last major step is elaborating the scenarios. There are 4 kinds of scenarios. There are state change scenarios, state view scenarios, external state input, and external state output. The state change ones are basically follow the given when then. Actually, all these follow given when then or given then. So it makes them very testable. But in this stage, you're basically lining up what the rules are for how a state transition will occur given the events that are occurring ahead of time. So you're basically making requirements. You can't book a room for a guest until the guest has been registered and the room has been added. Pretty simple, but these are those business rules, right? A sales report requires paid events to compute or to go into the sales report itself. External state input and output are interesting because the external state input one, especially, you're using external events that happen outside of the CQRS system and turning them into events that are inside the system. So GPS updates. We have a feature in this particular story where you say, when I leave the room, or when I leave the hotel, I want you to clean my room. So we need to identify from your GPS on your phone when you actually leave the hotel. So those events are occurring. The blue sticky there is coalescing them and deciding, okay, now I'm going to generate an entered hotel or exited hotel event based on this input coming from the external system. So you use these 4 types of scenarios and you line them up for all the state changes, all these different things you have to keep track of based on the events and commands and the views that are associated with them. So events, commands, views as asynchronous APIs is something I've been interested in. We have seen some cases where this is useful and others where it doesn't help as much, but because this is an AsyncAPI conference, I really want to talk about how you would do this in AsyncAPI. So the basic idea is you publish commands and you subscribe to events. So if you're familiar with AsyncAPI, there are basically 2 types of channels, 2 directions. The commands channel and the events channel are line up with the blue and the orange stickies. I didn't use the bright colors because it's a bit bright. One of some of the good parts about this approach, we're using asynchronous calls to receive and send these, is you can do a fire and forget strategy where you want to send commands. You don't really need validation that they occurred. Whatever effect they have is whatever the effect is going to be. You're not really that fussed. So you're just going to do it. So a good example of these, the user interface events like mouse moves, the GPS tracking is another one. You need to send these commands quickly, but you don't really care so much if they actually do anything. You're going to use the views to compute what you can do next based on what the views come back as. It's also useful for one or more delivery. If you run certain of how fast your system is going to be, or you really need the command to occur, you can fire the same command multiple times down the asynchronous channel, and then listen for the event channel, and then do your own matching. So events have a causation ID that lines up with the command ID, so you can use those to determine if the command was successfully executed, and you can know that the system is going to ignore all the subsequent commands that match that command ID. So it's a good way of making sure that your commands are actually getting through. There are some downsides to this, which are you don't have a call response approach to give you failure feedback. So if a command fails because of business rules, you have to have a channel for that. It's not here, but you can imagine an errors, or maybe the events channel has an error event coming through. But you have to design a way to track, if you care, if your command failed. If you do care, then the causation linking is on you, and it's a little harder because you're going to have to keep track, right, of what you've sent as a command and what events have come back. If for some reason your application goes offline and you come back out of the box, AsyncAPI does not have a concept of catching up. You have to build that protocol into your API yourself. And some people are apparently doing this, but it's not part of the spec to do this. So that's a couple of the downsides of using AsyncAPI for publishing commands and subscribing to events. The part I like a lot about AsyncAPI for event modeling is the views. Views are naturally a subscribable source, and it's really nice because views by definition are current state only. They don't have the notion of replaying what you've missed. When you subscribe to a queue, the data you get is the most current view. It's not sequential in nature where you have to replay through. If you need to have something like that, then that's part of the view itself. These are data-centric objects, so they send out data, and then a listener will transform that data into what their endpoint needs to show. So it could be you need to update a React view or a React model. It may be that you need to generate a PDF file and drop it in a hot folder somewhere. You may need to make a SQL call to update a database. Whatever it is you do, there's a separation between the view subscription and the reaction to that data that comes down the view at that endpoint, which is good for serverless architectures. Okay, so event modeled, how does this look in the actual AsyncAPI code? So I'm going to switch over to a small project I've written called Hotel Management API. It's a WebSocket project. You can use obviously the protocols, but I'm familiar with WebSocket, so that's what I've been using for this. The channels I've created, one is called, sorry, I slid past, is the register channel or the guest channel with a register command, and it's a publish because you can publish commands, and its headers contain the data, the metadata about the command. I'll show this in a minute. But the payload is simply the data, the information you want to capture that's business related. So the user wants to register, they get to get the first name, their last name, and their email address. Matching it will be the registered event, which you can subscribe to. Its headers are again the same as far as they're a separate concept. Its payload is identical to the command. This is very common. It's not always this way, but I'd say 90-95% of the events that are created by commands have the exact same payload as the command itself. In a way, it makes sense because a command is a request to create an event, or it's a request to make a state change. And most of the time, you're just checking in the command handler is this allowed? You know, if I'm trying to delete an account, is there an account to be deleted? Or do I have, you know, the rights to delete the account, or whatever your business rule is that you have to enforce at the command handler? You're making a yes or no decision, should this event occur? And so the data would match. Like I said, it's not always the case, but it's often the case. And so it's really nice that AsyncAPI lets you do references like this to that data. You can also obviously put these in components. That might be a better case, but just want to make the point about this data being the same for most cases. I've got a book guest command, and it looks very similar. It's got a guest ID, booking ID, check-in dates. So it's nice having the JSON schema format to define the payloads. And guest book, as again, has a reference to the book guest command. A note about the operation IDs. These names are look more like what you'd expect from the coding side. And so I think there is some tooling that would generate out classes that use the operation ID as the object name or the class name for the data in this payload or in this message. So that lines up really nicely with a generated program model coming from this specification. Views are a little different. We're past it. A view, you know, I use a parameter to describe what hotel I want to subscribe to the views. In the commands, I didn't use these. Commands, as I'll show you in a minute, often have in their metadata header will have the entity ID that describes what entity is being operated on with this command. Hotels are more query based. You don't want to see all the hotels, perhaps you just want to see this hotel. So it takes a parameter. These obviously can be more than one kind of ID parameter, whatever you need it to be. It's up to you to decide. The payload has some similarities to the events. One thing I want to note is you're going to be creating views to serve or view data to serve the views specifically. So this particular view wanted the guest name to be full name as opposed to first and last name. The reason, I don't know why, I'm just pointing out that the data you get in the event doesn't exactly match the data you send out. So what you don't want to do is refer to properties on the event in the view model. You want to basically separate that relationship between the event data and the view data, because you don't want that that hard link between the two. Views are easy to write. Views are standalone. They're not really supposed to be sharing data references directly to the events. And so this is a way to show this point. It's a string. How you compute full name is something you put in a note with the view definition itself in the event model, but it doesn't show up in the async API. And then the components. So the shared headers, I should probably start at the end and go backwards to explain. Shared headers is command headers, and it's basically all the shared headers plus a command ID. The event headers are all the shared headers and the event ID, which shows it's essentially the same thing. It just has a different ID. Their types are even the same. They're both UIDs. But again, the semantics of what they're for make all the difference as to why they're the same, yet they have two different types for describing what it is they're for. So the shared headers, you have the entity, which is the thing you're operating on, the thing in the real world, the key. So how do you identify this hotel from that hotel or this guest from that guest? The actor, we've talked about actors in the event modeling framework. This is the person who is, or the role that is actually executing this command or executed this event. Causation ID, this is how you can trace, this is very similar to other eventing systems. Command that generates an event, the causation ID of the event is the command ID. Correlation ID is, you can send down correlation IDs, and that covers a set of commands and events. So you could create a saga with this, or some like a batch job, something large you want to group together, multiple operations, state changes, view responses. All these things need to be grouped together by a correlation ID. This is something that you can pass it down through in the event. The only two that are required are entity and key. The others, you could obviously grow this to make actor required, but causation and correlation are also not required, but they may need to be part of your system if you obviously have to have them. Okay, so this is really cool. I'm going to generate, I did this once, but I'll do it again, using the AsyncAPI tooling to generate a Node.js project. And it's thinking about it. This is quite exciting for me. This is sort of the payoff of, one of the big payoffs of doing this is a generated source. So if I go into the API and I look at the handlers, right away you can see I've got command handlers generated that will accept that command and generate out the event. This is, or write the event into an event store. So this is really nice. Here's that operation ID I was talking about before. For views, you've got basically when the events come in, you can populate your view from that. You will often obviously inject other lookups to the event store to get data from other parts of the system to populate your view. This is a way to coalesce multiple events together. But this output creates the routes and the WebSocket and everything you need. That's not it, sorry, to get started on building out your system. So this is a really nice tool set and a good reason to use AsyncAPI to create these event model systems. So thank you for your time. I think we're going to be taking questions. If you have further interest, please visit these sites. There's a nice Slack on Twitter, a Slack channel. There's a link here. If it's in the slides out, you can go to the eventmodeling.org website and find the same link there. And then you can follow Event Modeling on Twitter and start learning more about this exciting way of developing event-driven, event-sourced CQRS systems.
All right, so that was the last talk of the day from Matt Bishop. I think it's been a really great talk. Let me have a look at the chat. In the meantime, Matt, maybe you want to say something. You want to add something to the talk itself, or to add some comments.
We had to record it earlier, so as I was recording, I was also learning about some of the new protocols that I can use to solve some of the not good parts, as I put it in the talk. So I'm looking forward to digging into some of those to see about the correlation, especially is interesting, as well as some things around catch up. So I'm also interested in learning more about the non-WebSocket based approaches, how you can use something that's more long-lived or long connected, going through the multiple systems, like I can't remember who I was talking about earlier in the conference, but it's
Mercure?
some interesting things, yeah, that can be explored. Like event modeling is something I've been involved with. AsyncAPI is new, so a lot of this is a learning exercise, and thank you for the opportunity to talk about it and to share something I'm really interested in with event modeling and building systems using that approach.
That's great. So actually, I think I've always been thinking that we should pay more attention to event modeling, and probably kind of combining somehow, or at least some training material or documentation material on how to use both together with the AsyncAPI, right? Because it really makes sense if you think about it. It's all about events in the end, right? So both things are about events. So it should be possible to use them together. And I'm glad that you joined the community and started, speaking about exploring more about this combination of both. I think it's a really interesting point. So I have a question here from Gerald Loeffler. I think I'm pronouncing it correctly. Sorry if not. He says, at what point do you add version information to your commands, events, views?
Versioning is obviously a great topic. James was talking about that earlier, and I think his advice is solid. You add properties, you never rename properties. If you're gonna, like, those rules apply to every situation. The event versioning is not, there's nothing unique in event modeling about how to version events. So I think you can look to that advice. One thing, Greg Young's been working on a book on versioning events, and especially in CQRS systems. So you can look for that. I think there's an online preview of it you can get. But it's definitely a topic. The nice thing about the event modeling sessions is because you're with the actual people, the actors, the humans that are doing the work, it's a lot less likely you're going to get it wrong, right? You're going to, because they can see it on the wall or on the screen, and can talk about what they're doing when they're, you know, working to fulfill an order or cleaning a guest room or whatever it is. The opportunity to misunderstand is very low, and they're involved in the process as you go through. When you create the software, they test the software that you make. You're going to find there's not a lot of mistakes made at that initial point. You know, over time things change, and that's how life is. So versioning comes into play then, and so as an organization, they have to decide: do we add as we go, or do we create versions? There's a lot more factors outside of just the event modeling approach that come into play when it comes to versioning. But I just initially, with event modeling, you don't end up making a lot of the mistakes you normally make with just a BA who goes and talks and then comes back, right? You don't have that air gap between the people using the software and the people building the software.
Right, agree. So actually, I think just to add a little bit about it, I think in terms of tooling, something that it's helping a lot with versioning is schema registries. So for those who are not familiar, this is like a central repository of your schemas or event schemas. There's this Confluent schema registry, and it has an interesting feature that you can configure it to so it blocks you from trying to deploy a new version of the schema that has a breaking change. So it doesn't allow you to do that. It's configurable. So if you try to register a new version of event that has a breaking change, bang, it tells you that that's not possible, right? So that's, I think that's a pretty cool feature. And it's not just a schema registry from Confluent. I know that Red Hat has also is developing one, and then you have Supermodel as well from Zenek Nemec. I hope he's here watching us today, if not one other day. So he's also been doing a great job with Supermodel.io. So yeah, just to add this part, right? So is there anything else you want to comment? Because I don't think we have any questions, right?
Just come on and join the groups if you want to learn. I know that there's some in-person workshops that have been happening. It's a really great experience. Obviously, we're not doing in-person now, but there are some online ones. So if you want to participate digitally, they're very code heavy as well. So if you don't like a lot of talking heads, but like to get your hands dirty, actually writing code as you go, then these online workshops are a really good experience to get involved and see how to actually construct these systems in software, as opposed to just the modeling. You do both the modeling and the building, and it's, they're a lot of fun. So please join up and contribute your experience and help us move this forward. And making specifications are critical. We don't have a specification outside of a Miro board right now. I think it's a piece that's been missing, and that's something I'm interested in working on with like AsyncAPI and OpenAPI as well, to create those boundary specifications. And like Fran was saying, the schema registries to describe these in outside of the context of a particular channel. So this has been great for me to be a part of today. Thanks.
Thank you. Our pleasure. So Matt, we'll have to let you go now, and as we're finishing, thanks for joining us. It's a great pleasure to have you, and I think we're pretty much done today here. We're not gonna make a break for the closing words. So we're going directly to into the closing words right now. Let me activate the video for Eva, which I cannot do. Can you do it yourself? ¿Te puedes activar el video?
¿Qué?
El video.
¿El final?
Es tuyo. So yeah, let me just tu cámara. Okay. Live and direct. So yeah, and well, folks, thanks for joining to this great experience that we had today. It's been an amazing day, an amazing experience trying to come up with this online conference and putting everything together in less than in about 3 weeks, which has been like super crazy. So yeah. Do you want to say something, Lucas, maybe?
Yeah, actually, I have long list.
Yeah. Okay.
Should I now jump in? Yeah, I just wanted to have it in the recording. So I wanted to send a huge thank you, first of all, to the sponsors of the event. So it's API Realtime, SmartBear, MuleSoft, Red Hat, API Initiative, OpenAPI Initiative, Solus, and also our golden sponsors, Slack. So you invested in the event. Make sure we're going to make sure that we're going to spend your money on marketing of this recording and this awesome conference. So no worries, your money will be well spent. Then next round is presenters. Like, people don't know, but actually only people that were in our Slack and are close with the community know that presenters actually had only 3 days to submit proposals, and they like made it awesome. And also they had a double effort. They had to record the sessions a week before the event, and they also had to be with us here answering your questions. So it's really a double effort from their side.
Yep.
And so huge thank you, and we're going to contact you, dear presenters, because we have a gift for you as a thank you from AsyncAPI initiative. Next round, community. Awesome that you joined us. Really awesome that you were helping us with the ideas and comments in Slack how to organize the conference. So I hope you're staying with us longer. At the end, I would like to again thank 4 amazing people that helped us with the call for papers to make it to make the program of the conference really nice. So it's Andrzej Jarzyna ze Szczecina. You're gonna like this inside joke. Jonas Lagoni, Mike Ralphson, and Walid Ashraf. So guys, you're awesome. Thanks a lot. That's not it yet. And last but not least, media. So there are many people, many communities preaching about our event. So thanks to Axway, Gopher Silesia, Lunch, Any, Solus, API Days, and API Scene. Thanks a lot for talking about the event to your communities. And that's last but not least. Thanks a lot to Emmelyn for everytimezone.com. She referred this tool to us. I don't think we would be able to prepare such a schedule across all the time zones without this awesome tool that translated all the different time zones to us. Next one is OBS project. So I didn't know about this tool before. I learned about it from Eva and Fran. So it's an cool open source project that we use here, not only Zoom and YouTube, but also OBS to do the streaming and have nice logos of the partners in the video. So it's awesome. And last tool that I want to thank is it's like my beloved wife, that she took a day off, so my kids are not jumping on my head, and I could actually be here with you and help out to moderate the meeting. So my wife, thank you, Karina.
You called your wife tool?
Yeah, I mean she's my beloved.
Come on.
true not tool, but yeah, huge helper to the community, really behind the scenes.
That's true. That's true.
So that's it. Stay safe, stay home.
Yeah, stay safe. Yeah, let's keep chatting on Slack and Twitter. If you're not there on Slack yet, feel free to join. You can find the link on our website. And yeah, next week we have our community meeting. So also feel free to join us and to make proposals or just to say hello. We love to meet new people. So yeah, join us. Thanks a lot. Sorry for the long list of Lucas that he hid this to me, so we didn't know. That was expected. So yeah, thanks a lot again, and hope to see you soon. Bye bye.